Hi guys, welcome to my channel. In this video, I will be covering complete unit 1 in DBMS subject. I will explain all these topics in detail, and whatever the topics that I am going to cover in this video, I will provide all those topics and their timings in description. So before starting this video, please check in description. Guys, I have uploaded complete DBMS subject tutorials. I will provide link in description, you can watch from there. I will provide this unit 1 study material link in description. You can download from description. If you are watching this video for the first time, don't forget to like, share and subscribe to my channel. Let's get started. At first I will explain what is database. But before starting this, you need to know what is difference between data and information. At first I will explain what is data. Data is a raw, unorganized, unprocessed fact. And whereas information is the processed, organized data that is beneficial in providing useful knowledge. Guys, data is nothing but it is a raw fact. And whereas we call information as processed data. Guys, I will give one example so that you can clearly understand what is data and information. Let us consider I written some numbers like 27935. This is an example of data. Data is nothing but data is a raw fact that don't have much meaning. Yes, 27935. These are numbers. It is a fact. But what are these numbers? Either these numbers are student marks or student roll numbers. We don't know. So we call it as data. Just in place of writing 27935, I will write here student scores 23579. Now we call it as information because it has meaning, like this numbers belongs to student scores. So we call it as information. Information is nothing but processed data. Next I will explain what is database. A database is an organized collection of structured information typically stored electronically in a computer system. I will explain this definition. For example, my database name is my database. Inside this database, I created one student table. Student table contains name Raju, Ramesh, Shiva and roll number 21, 22, 23 and section ABA. A database is an organized collection. Organized collection means in database, we will store data in organized format, like we will store all names in one place, all roll numbers in one place and section in one place. So we call it as organized collection. So a database is an organized collection of structured information. Structured information means in database we will store data in structured format, like we will store data in tables. Table is nothing but structured format. So a database is an organized collection of structured information typically stored electronically in a computer system. That is nothing but we will store database in computer. This is definition of database. A database is usually controlled by Database Management System. Shortly we call it as DBMS. Guys, DBMS is nothing but it is a software. By using this software, we can create database and as well as we can perform various operations on database. Like we can create table, we can insert data in my table, we can modify data and also we can delete data. A database is a collection of related data organized in a way that data can be easily accessed, managed and updated. Guys, in database we will store related data. For example, if you consider student table, in student table we will store only student information like student name, student roll number and student section. And similarly, if you consider employee table, we will store only employee information. In database we will store data in tables format. So it is very easy to access, manage and update data in database. Database can be software based or hardware based with only sole purpose storing data. Guys, database depends on both software and hardware. For example, if you want to create database or if you want to insert tables or if you want to insert any data in database, definitely we need database software. And in order to store data, we need hard disk. Hard disk is an example of hardware. So database can be software based or hardware based. And one and only purpose of database is to store data. Databases can store data in the form of tables depending upon the type of database. As we know, in database, we will store data in the form of tables. Guys, before starting this subject, you need to learn some basics like we call it as student table. We also call this table name as relation. Table and relation both are same. Don't get confused. And similarly, name, roll number and section. We call it as column names. And we also call columns as attributes or we can also call it as fields. All are same. And similarly, total there are 3 rows like Raju 21 and A section, Ramesh 22 and B section, Shiva 23 and A section. And total there are 3 rows. We also call rows as tuples or we can also call these rows as records. All are same. If you consider second row, Ramesh, rule number 22 and section B, we call it as row, or we can also call it as record, or we can also call it as tuple. So just you need to remember this. Next I will explain what is DBMS. DBMS stands for Database Management System. DBMS is nothing but it is a software that allows creation, definition and manipulation of database. DBMS is nothing but it is a software. By using this software, we can create database and also we can perform various operations on database. DBMS provides us with an interface or tool. By using this interface or tool, we can perform various operations like we can create database, we can create tables in my database, and also we can store data, we can delete data, and we can update data and so on. These are various operations that we can perform by using this interface or tool. DBMS also provides protection and security to the databases. That is nothing but we can keep password to the database management system software. So only users, those who have password, can access database. It also maintains data consistency in case of multiple users. Meaning of consistency is correct. Guys, not only single user, there are multiple users who use single database at a time. Even though multiple users use single database at a time, data will be in consistent format. That is nothing but data will be correct. Guys, these are some of the examples of popular DBMS used these days. They are MySQL, Oracle, SQL Server, IBM DB2, PostgreSQL, Amazon SimpleDB. All these are examples of popular DBMS used these days. Edgar F. Codd is the founder of Relational Database Management System in early 1970s. Relational Database Management System is nothing but data which is stored in the form of tables, that is in the form of rows and columns. Next I will explain characteristics or features or advantages of DBMS. Guys, for these three questions you can write this answer. Guys, DBMS is nothing but it is a software. For example, MySQL software. By using this DBMS software, we can create database, we can insert tables inside database, and also we can perform various operations on database. This is first feature of DBMS software, that is data stored into tables. In DBMS, we will store data in the form of tables. If we store data in the form of tables, then it is very easy to understand. By looking into the table, you can easily identify what type of data is stored in database. Next feature is reduced redundancy. Meaning of redundancy is duplicate values. In DBMS software, we can remove duplicate values. If we show duplicate values in our system, then our system will occupy a lot of memory. For example, this is student table in my database. In this table, name Sai, rule number 21 and section A repeated twice. That means this table contains duplicate values. In DBMS, there is one technique called normalization technique. By using this normalization technique, we can easily remove duplicate values. So by using normalization technique, I remove these duplicate values. In DBMS, we can reduce redundancy. Redundancy is nothing but duplicate values. We can reduce duplicate values. And third feature is data consistency and data sharing. If there are no duplicate values, then automatically our data will be correct in database. Meaning of consistency is correctness. In DBMS, data will be correct. And data sharing means multiple users can share data at a time from different locations. For example, one person is in Hyderabad and next person is in Delhi. So by using this DBMS software, these two persons can communicate each other. Without depending on location, users can share data between each other. Fourth feature is support multiple users and concurrent access. Meaning of concurrent access is parallel access. That means at a time multiple users can access database. By using this DBMS software, multiple users can access database at a time. And fifth feature is query language. Normally, if two persons want to communicate between each other, they can communicate in English language or Telugu language or any other languages. But this database management system software cannot understand English language or any other languages. In order to communicate with database management system software, there is one separate language called SQL, that is Structured Query Language. By using this Structured Query Language, we can easily communicate with database. By using this language, we can easily insert, update and delete data in database. Next feature is security. Security is nothing but we can keep password to our database management system software. And also we can give various access permissions. For example, there is student table in my database. Whereas for faculty, we can give read permission and as well as write permission. That means faculty can read data and as well as faculty can write data. And whereas for student, we can give only read permission. We cannot give write permission. If we give write permission for student, then you can easily modify data which is present in table. So for faculty I given read and write permission, and whereas for student I given only read permission. So in this way we can give various types of permissions to various users. Next feature is data integrity. In database management system software, we can use integrity constraints. Guys, integrity constraints are nothing but rules. We can give various types of rules while creating tables. So by using those integrity constraints that are nothing but by using those rules, we can maintain correctness and completeness of data. That means data will be correct and data will be complete in database. And next feature is backup and recovery. Guys, database management system software contains automatic backup. Automatic backup is nothing but this DBMS software will store our data in multiple locations. So if we store our data in multiple locations, so even though if any data loss occurs, then we can easily restore our data. Backup is nothing but creating multiple copies of data. And recovery is nothing but restoring our data in case of data loss. Next I will explain disadvantages of DBMS. Guys, there are some disadvantages of using this database management system software. They are: first disadvantage is cost of hardware and software. If you want to install DBMS software in your system, then your system must contain high hardware. Your system must contain high hard disk, high RAM, high processors and so on. So if you want to install database management system software, at first you need to purchase hardware. And next one is cost of software. Guys, there are so many database management system softwares, but all are not free. Some DBMS softwares are costly. So you need to spend money in order to purchase database management system software. So first disadvantage is cost of hardware and software. And next disadvantage is complexity. All users cannot use database management system software because in order to use database management system software, at first you need to learn SQL, that is structured query language. Only people having knowledge on structured query language can use SQL. So DBMS is complex. And next one is high storage. Guys, in database management system software, we will store huge amount of data. So we need high storage. And next disadvantage is depends on DBMS vendors. Guys, DBMS vendors are people who provide us DBMS software. For example, I purchased Samsung mobile, but I cannot update that mobile. Only Samsung company must provide me updates. So if Samsung company provides me updates, I can update that mobile. So in same way, I cannot directly update DBMS software. Person who given me this DBMS software, that person must provide me updates. So we cannot directly update DBMS software. We completely depends on database vendors. This is another disadvantage. And next disadvantage is data security risk. Even though if we are using various types of security mechanisms in order to provide security to our database, still our database is not completely secured. We cannot give 100% security to our database because nowadays many hackers are implementing new techniques in order to hack database. So we cannot give 100% security to our database. And next disadvantage is high impact of failure. In DBMS software, we will store our data in one location. So if any failure occurs, then our complete data will be deleted. These are disadvantages of DBMS. Next I will explain database tasks in DBMS. Guys, database tasks are nothing but operations. In DBMS software, we can create database and also we can perform various operations on database. I will explain all these operations in detail. First one is data definition. The name itself says data definition. That is nothing but just defining structure of our database, like creating tables, creating columns and as well as establishing relationship between tables. All these three operations comes under data definition. For example, in my college database, I created student table. Student table contains three columns. They are name, roll number and section. I did not insert data. Just I created structure. That is, I created student table and just I inserted three columns, name, roll number and section. So we call it as data definition. Guys, we also call data definition as schema definition. Meaning of schema is structure. Data definition means just creating structure. And whereas data manipulation means inserting data inside database. For example, in student table I inserted data like name Sai, roll number 21 section A, name Shiva, roll number 21 section B. This is simple example of data manipulation. Not only inserting but also updating data, deleting data. All this operation comes under data manipulation. For example, I will change name Sai to name Nagendra. And for example, I will delete this complete record, Shiva, roll number 22 and section B. All these operations comes under data manipulation. We also call this data manipulation as query processing. And next one is data retrieval. Data retrieval is nothing but receiving information from our database. For example, I want to get information about student whose roll number is 21. Retrieving our required information from table is known as data retrieval. Guys, data definition, data manipulation and data retrieval. All these operations are performed by using structured query language, that is SQL. Next one is data security. That is nothing but we can give password to our database and also we can give various access permissions to various users. For example, if you consider student, we can give only read permission. And whereas if you consider faculty, for faculty we can give both read and write permissions. Like that we can give various kinds of permissions to various users. And next task is data integrity. Guys, in DBMS software we can use integrity constraints. Guys, integrity constraints are nothing but rules. We can apply various rules while creating table. If we apply various rules while creating table, then our data will be correct and complete in database. So data integrity is nothing but correctness and completeness. Next task is backup and recovery. Backup is nothing but storing our data in multiple locations. And whereas recovery means restoring our data in case of data loss. If we store our data in multiple locations, so if any data loss occurs, then we can easily restore our data. And last task is concurrency control. Concurrency control means multiple users can access DBMS software at a time without depending on location. Even though multiple users access DBMS software at a time, there will not be any problem. Next I will explain applications of DBMS. Guys, in many fields we will use DBMS. Let us see some of the applications where DBMS is used. First one is railway reservation system. In railway reservation system, database plays very important role. For example, I went to railway station and I purchased a ticket to Vijayawada. Now my information is stored in railway database. Like what type of ticket I purchased, at what time I purchased and what is cost and my name, everything is stored in railway database. Not only ticket booking information, but also this railway reservation system database stores various information regarding trains. Like what are the trains available at present, at what time train will arrive and at what time train will start, and also it gives information regarding late trains. All this information is stored in railway database. And second application is library management system. Normally libraries contains thousands of books. Library database will store various information regarding books, like what types of books available in library and name of the book author, how many books issued to customers who will visit to libraries daily. All this information is stored in database. And third application is banking. We use database in banks. Daily in banks there will be thousands of transactions, like how many people withdraws money, how many people deposits money and so on. All this information is stored in database. And fourth application is universities and colleges. Nowadays many colleges and universities are using database management system. Universities and colleges stores various information in database by using database management system. They will store information like student name, student details, student fee structure, student course, and also faculty information, faculty salary, marks and grades of all students and so on. All this information is stored in universities and college databases. And fifth application is credit card transactions. Like how many items you purchased by using credit card, all this information is stored in database. And this credit card information is secured. No one can hack this credit card information. Seventh application is finance. Nowadays many of them are investing money in finance. All this information is stored in database. And next one is military. We also use database management system in military in order to manage military database. Military database contains information regarding soldiers, like how many soldiers are working, their names and so on. This military database also contains information regarding various military assets, like how many aircrafts, how many military vehicles available and how many weapons are available. All this information is stored in military database. This database also contains information regarding our country's security. And next application is online shopping. Nowadays many of them are purchasing products online. For example, I purchased one product in Amazon. Now whenever I purchase product in Amazon, all my information is stored in database. Like my name, what type of product I purchased and purchase date, all this information is stored in database. And 10th application is human resource management. Nowadays in each and every company we are storing employee details like employee name, employee joining date, employee salary, employee tax and so on. All this information is stored in database. Next one is manufacturing. Even in manufacturing companies we use database management system software in order to manage database. Manufacturing company database contains various information regarding products which they are manufacturing. For example, if you consider one company is manufacturing soap, so it will contains all details regarding their soap product, like how many soaps they are manufacturing daily and various chemicals that they are using in order to manufacture soap, daily how many supplies are going on. All this information is stored in manufacturing database. And next one is airline reservation system. It is same like railway reservation system. Airline reservation system contains information regarding airway passengers, like person who purchased the ticket, his name, at what time he purchased the ticket. And this airline reservation system also contains information regarding flights, like at what time flight will arrive, at what time flight will start, and any flight delay status. All this information is stored in airline database. So we also use database management system software in airline. All these are various applications of database management system. Applications of database management system is nothing but in various fields we use database management system software in order to manage database. Next I will explain history of DBMS. DBMS stands for database management system. This DBMS is nothing but it is a software. By using this software we can manage database, like we can create database, we can insert data, we can delete data, and we can modify data which is present in database. DBMS was first developed in early 1960s in order to manage huge amount of data for scientific and military applications. Whatever the database management system software developed in early 1960s, the software is used only to store data and retrieve data, but we cannot perform any modifications on data. Just we use this software in order to store and retrieve data. And the software was designed for mainframe computers. Guys, mainframe computers are nothing but old computers which was developed in the year 1944. The early database management system software was integrated data store, which was developed in the year early 1960s. We call this early database management system software as integrated data store. This integrated data store software will support data definition language and data manipulation language. And next in 1970s. In 1970s, relational model was developed by Edgar F. Codd. He is the person who developed relational model. Relational model is nothing but data which is stored in the form of tables, that is in the form of rows and columns, is known as relational model. In relational model we can use normalization. Normalization will improve data integrity and eliminates data redundancy. The first relational database management system software was developed by IBM in mid 1970s. Some of the popular relational database management system softwares are Oracle, Microsoft SQL Server, MySQL, PostgreSQL. All these are examples of relational database management system softwares. And next, in 1980s, actually there are some disadvantages in relational database management system. So in order to overcome these disadvantages, object-oriented database management system was introduced. The name itself says object-oriented DBMS. In object-oriented DBMS, we will store data in the form of objects, which contains both data and as well as procedures that operates on the data. In object-oriented DBMS, we can store pictures, audios, videos and other type of data, where it is impossible to store in relational DBMS. Just remember these points. In object-oriented DBMS, we will store data in the form of objects, not only text information, but also we can store audio, video and pictures and so on in object-oriented DBMS. But still, this object-oriented DBMS is not recommended. In 1990s, web-based DBMS was introduced, which allows the users to access data through the web browser. Directly by using web browsers like Google Chrome, Firefox, we can access databases and also we can perform various operations on databases in internet itself. Even though if users are in different locations and users are using different systems, users can easily access database through internet. And next, in early 2000s, NoSQL database was introduced. This NoSQL database use non-relational data models. In NoSQL database, we will not store data in the form of tables. In NoSQL database, we will store data in the form of classes and objects. For example, I want to store two records in relational database. One student name is Raju and age 25. So I can store that information like Raju and 25. Next time, I don't want to store age, I want to store rule number of another person. That person name is Ramesh. So again, name column is already present, so I can write here Ramesh. Again, I need to create rule number column in order to store rule number of Ramesh. So I am storing rule number, that is 55. For example, there is third student name is Shiva. This time I want to store name Shiva and section A. So name is already present, so directly I can insert Shiva, and the section column is not present. So again I need to create section column and I need to write section A. So for a single record I need to create separate column. This is waste of time. So in order to overcome this problem, we can use NoSQL database. JSON is example of NoSQL database, where JSON stands for JavaScript Object Notation. In NoSQL database, we will not store data in the form of tables. Instead, we we will store data in the form of class and objects. This is example of JSON. Here I took name Sai and rule number 20. And again I took brackets. Inside brackets I written name Ravi, section A. Guys, among all these databases, relational database is best. Next I will explain what is SQL. Full form of SQL is Structured Query Language. Normally if you want to communicate with any person, we can communicate with English language or Telugu language or Hindi language or any other languages. But if you want to communicate with DBMS is nothing but it is a software. Example like MySQL software. This DBMS software cannot understand English language or Hindi language or any other language. So in order to communicate with database management system software, there is one separate language, that is SQL. By using this structured query language, we can communicate with database management system software. If you want to create database, or if you want to insert table, or if you want to insert, update or delete data in table, inside database management system software, you need to use structured query language in order to perform various operations on database. SQL is a programming language that is designed in order to manage and manipulate relational databases. Relational database is nothing but data which is stored in the form of tables is known as relational database. We can perform various operations on relational databases by using structured query language. It provides a standardized way to interact with databases by allowing users to perform various operations such as creating, retrieving, updating and deleting data. By using structured query language, we can perform various operations on database, like we can create database, we can create tables inside database, we can insert data, update data or delete data, and also we can retrieve data by using SQL. SQL is used to communicate with a database management system. Guys, database management system is nothing but it is a software, and the software is used to manage databases. Some of the popular database management system softwares are MySQL, Oracle, SQL Server, PostgreSQL and SQLite. All these are examples of database management system softwares. Guys, if you want to perform any operation on database, then you need to write SQL queries so that our DBMS software will execute those queries. SQL was developed by a team of researchers at IBM led by Donald D. Chamberlain and Raymond F. Boyce in early 1970s. These two persons are team leaders. They developed SQL in late 1970s. The project initially called SQL, that is Structured English Query Language. Actually, first name of SQL was SQL, that is Structured English Query Language. But due to some trademark issues, they changed the name to SQL. Trademark conflicts are like copyright conflicts. Already some other companies took this name, so they changed the name to SQL. SQL was then published as standard by the American National Standards Institute in 1986. In 1986, American National Standards Institute published this SQL. And later ISO published this SQL in 1987, where ISO stands for International Organization for Standardization. From that day onwards, SQL has become standard language, and many of the DBMS softwares are using this SQL in order to work with relational database. Relational database is nothing but data which is stored only in the form of tables, that is in the form of rows and columns is known as relational database. This SQL works on relational database. Next I will explain difference between file system and DBMS. Guys, file system is nothing but text file. When computer was first introduced, we used to store our data in text file. For example, I open notepad in my computer and I will write some text like my name, rule number, section and so on. Now I will save this file with name file.txt. As we know, we will save text files with .txt extension. So I will save this file with name file.txt. File-based systems were an early attempt to computerize the manual system. Manual system is nothing but physical record like books. Books is an example of manual system. In olden days when computer was not at all introduced, we used to store our data in books. But later on when computer was first introduced, we used to store our data in files. Guys, we also call file system as traditional based approach, or we can also call it as decentralized approach. What is meaning of this decentralized approach? For example, if you consider DBMS, we call DBMS as centralized approach. Centralized approach means all data is stored in one place is known as centralized approach. For example, let us consider there are 3 employees. One employee wants to store student details, and next employee wants to store subject details, and next employee wants to store student results. In single database itself, these employees can create 3 different tables and they can insert data. So in single database, we are storing all this information. So we call it as centralized approach. In file system, we will not store data in one place. Instead, we will create 3 different files in order to store 3 different informations. So we call file system as decentralized approach, whereas centralized approach means all data is stored in one place is known as centralized approach. And whereas decentralized approach means for different information we need to create different files. So we also call file system as traditional based approach, in which a decentralized approach was taken, where each department stored and controlled its own data with the help of data processing specialist. In decentralized approach, each department will store and control its own data with the help of data processing specialist. The role of data processing specialist is to create files and manage files. This is simple structure of file system. For example, I want to store student information like student name, student roll number, student section, student marks and so on. So for that purpose, I need to create one separate student file. And similarly, I want to store subject details like subject name, subject ID, subject room and so on. So for that purpose, again I need to create one separate subject file. And I want to show result of the student. It contains details like student name, student roll number, subject name and marks and so on. So for that purpose, again I need to create one separate result file. So for different details, we need to create different files. Guys, there is one disadvantage in file system, like only one person can view one file at a time. For example, this person opened this file. So whenever this person opens this file, this person cannot access this file. Only if this person closes this file, then he can access. So only one person can view file at a time. And whereas in DBMS is centralized approach. So multiple users can view DBMS at a time. DBMS is nothing but it is software. For example, let us consider these 3 students open this database management system at a time in order to check marks. So at a time, the 3 persons can check marks. By using DBMS, multiple users can view data at a time. A database approach is a well-organized collection of data that are related in a meaningful way, which can be accessed by different users but stored only once in a system. That is nothing but, in database we will store data in organized format, like we will store all names in one place, roll numbers in one place and so on. And we will store this data in tables format, which is very easy to access. And not only single user, there will be multiple users who will use database at a time. And whatever the data that all these users will store, this data is stored in single database. The various operations performed by DBMS system are insertion, deletion, selection, sorting and etc. By using database management system software, we can perform various operations on database, like we can create tables inside database, we can insert data, we can delete data, we can modify data, we can update data and so on. This is simple structure of DBMS. All these 3 files are stored in DBMS. So multiple users can access all these files at a time. Guys, in DBMS we will store data in tables format, like student details in one table, subject details in one table and result in one table. Guys, DBMS is nothing but it is a software. By using this software, we can create database, we can insert tables inside database, we can insert data, delete data and so on. Guys, these are following differences between DBMS and file systems. The file system is a software that manages and organizes the files in a storage medium within a computer. For example, if you consider Notepad, Notepad is example of file system. And we will store these files in storage medium like hard disk in computer itself. And whereas DBMS is nothing but it is a software. By using this software, we can manage database. Like we can create database, we can insert tables, data and so on. Next one is data redundancy. Duplicate data can be present in file and there is no duplicate data in DBMS. For example, in file, name Sai, roll number 21 and section A repeated twice. Files cannot automatically identify duplicate values. So we cannot avoid duplicate values in files. And whereas in DBMS, for example, this particular record name Sai, roll number 21 and section A repeated twice. In DBMS, there is one technique called normalization technique. By using this normalization technique, we can easily identify duplicate values. So we can avoid duplicate values in DBMS. Data redundancy is nothing but duplicate values. Whereas in file, we cannot remove duplicate values. But whereas in DBMS, we can easily identify and remove duplicate values. If there is no duplicate values, then data will be correct in DBMS. That is nothing but we can achieve consistency, that is correctness of data in DBMS. File system will not provide any backup and recovery, and whereas DBMS will provide backup and recovery. For example, suddenly I deleted data which is present in my file. Once if we delete any data inside my file, we cannot restore the data. For example, suddenly I deleted data which is present in database. So even though if we delete data in database, we can easily restore data. There is no efficient query processing in file system. And whereas in DBMS, there is efficient query processing. For example, I want list of students who filled in exam. So simply by writing query, we can easily find result of students who failed in exam. But whereas in file system, there is no efficient query processing. There is less data consistency in file system, whereas there is more data consistency in DBMS. In DBMS, there is one technique called normalization technique. By using this normalization technique, we can easily identify duplicate values. By using this technique, we can achieve data consistency. Next one is complexity. File system is less complex and DBMS is more complex. Less complex is nothing but those who don't have any knowledge can also use files. But whereas in order to use DBMS, person should learn structured query language, that is SQL. In order to perform various operations on database, we need to learn structured query language. So DBMS is more complex. And next one is security. File system provides less security and whereas DBMS provide more security. And next one is cost. File system is less expensive when compared to DBMS and whereas DBMS is high cost when compared to file system. And next one is data independency. In file system, different data is stored in different files, so there is no data independency. But whereas in DBMS, all data is stored in single database, so there is data independency. And next one is user access. Only one user can use file at a time and whereas multiple users can use one database at a time. There is no need of writing procedures in files and whereas we need to write procedures in DBMS in order to manage database. For example, I want to get information about student whose roll number is 25. I need to write procedure like select star from student where roll number equal to 25. So it will display entire record of the student whose roll number is 25. But whereas in file system we will not write any procedures. Next one is sharing. As we know in files we will store different data in different files. So it is very hard to share data. And whereas in DBMS all files are stored in one place. So it is easy to share data. And next one is data abstraction. For example, if you consider file, in file it will give complete information like where file is located, file size and so on. And whereas in DBMS it will add complete internal details. It will just display data, but it will not display any internal details like size, location, it will not display anything. Just it will display data, that's it. And next one is integrity constants. Guys, constants are nothing but rules. We cannot apply any rules to files, but whereas we can apply some rules to database. For example, in this employee table, I applied not null constant to this salary column. Whenever we apply not null constant to this salary column, if we do not enter any value, it will not accept. So definitely we need to enter value. So in DBMS, we can apply many constants and whereas in files, we cannot apply any constants. Guys, last difference is file is unstructured and whereas DBMS is structured. Guys, structured means in DBMS, we will store data in the form of tables. But whereas in file system, we will not store data in the form of tables. Just we will store data in text format. So it is unstructured. Guys, in exam you may get different questions like explain difference between file system and DBMS, or you may also get question like advantages of DBMS over file system, or you may also get questions like disadvantages of file system or explain file system. For all these questions you can write this answer. Next I will explain data models topic in DBMS. At first you need to know what is data model. For example, I will go to builder in order to construct house. So that at first the builder will draw model of the house, like where hall is located, where kitchen is located, how many rooms and so on. So once if I see that model, I can clearly understand that how my house will look after construction. In same way, before storing any data in database, at first we need to create structure of database. So data model is nothing but creating logical structure of database is known as data model. Data model gives us an idea that how the final system will look like after its complete implementation. For example, if you consider relational model, in relational model we will store data in the form of tables like in rows and columns. Before actual implementation, at first we need to model our data like table name, how many columns that you want to insert and so on, so that we can clearly understand how data will be stored after implementation. Data model gives us an idea that how the final system will look like after its complete implementation. Data model defines the data elements and the relationship between the data elements. For example, if you consider there is teacher and there is department. As we know, teacher works for department. So relationship between teacher and department is work for. This teacher and department are data elements. So data model defines the data elements and the relationship between the data elements. Here relationship between this teacher and department is work for. Data models are used to show us how data is stored, connected, accessed and updated in database management system. Here we use set of symbols and text to represent the information so that the members of organization can communicate and understand it. Guys, in data models we use symbols and as well as text in order to represent data so that members in organization can easily understand. If you consider this example, in this example I am using both rectangle and rhombus, and I am also using text, that is teacher, works for and department. So we will use both symbols and as well as text. Once if you see this model, you can easily understand. So once if you see this model, you can easily understand. Guys, we call it as ER model. Though there are many data models being used nowadays, but relational model is the most widely used model. Guys, there are so many data models available, but among all this model, relational model is best. Relational model is nothing but data which is stored in the form of tables. Guys, I will explain all these models in detail. At first, I will explain what is hierarchical model. Guys, this hierarchical model was first a DBMS model. In this model, we will represent data in the form of trees. In this model, at first we will create root node and then we will keep on expanding this tree by adding child node to parent node. At first we will create root node, after that parent node, and we can add multiple children to parent node. Guys, this hierarchical model will represent real world relationships. Guys, this is simple example in order to represent relationship between shoes by using hierarchical model. Where the shoe is root node, shoes are classified into two categories. They are women's shoes and men's shoes. Women's shoe contains high heels and bellies, and similarly men's shoes contains sports shoes and sneakers. We call this shoe as root node and we call women's shoes and men's shoes as parent nodes, and whereas this high heels, bellies, sports shoe and sneakers are child nodes. Guys, these are various features of hierarchical model. First one is one-to-many relationship. In hierarchical model, we will represent data in tree-like structure, where there exists one-to-many relationship, like one parent can have multiple children. For example, if you consider men's shoes as parent node, these men's shoes can have multiple children like sports shoes and sneakers. These both are multiple children to this parent node. Next feature is parent-child relationship. Guys, in hierarchical model, there can be multiple children for single parent, but multiple parents for single children is not allowed. For example, if I write like this, it is not allowed because in hierarchical model, one children cannot have multiple parents. So there exists only one-to-many relationship. Third one is deletion problem. For example, if we delete one parent node, then child nodes are automatically deleted. And next feature is pointers. Guys, we call these lines as pointers. Pointers are nothing but they are links. They are used to connect parent with child. These are advantages of hierarchical model. Guys, actually in hierarchical model, we will represent data in tree-like structure. So it is very simple and also it is very easy to traverse. And next advantage is, if you make any change to parent node, then it is automatically reflected in child node. So it is easy to integrate data. And these are disadvantages in hierarchical model. First disadvantage is, this hierarchical model will not support complex data. It is suitable only for simple data. And next disadvantage is, single children cannot have multiple parents. That is why it will not support complex data. And third disadvantage is, if we delete parent node, then child node is automatically deleted. These are three disadvantages in hierarchical model. Next I will explain network model. This network model is extension to hierarchical model. In olden days before relational model, this network model is widely used. This network model is same as hierarchical model. Only difference is that in hierarchical model, single child cannot have multiple parents. But whereas in network model, single child can have multiple parents. Here is a simple example. This college is root node. This college contains CSE department and library. There are students in CSE department and there are students in library. So both nodes, CSE department and library, are pointing to students. Where this college is root node and the CSE department and library are parent nodes and the student is child node. Where these both parents are pointing to single child node. Where this is not possible in hierarchical model. Next I will explain features of network model. First feature is ability to merge more relationships. Whereas in hierarchical model, there is only one-to-many relationship. But whereas in network model, there can be one-to-one relationships and as well as many-to-many relationships. And next one is many paths. As there are more relationships, there can be more paths. So data access is fast and simple. And third feature is circular linked list. In network model, in order to perform various operations, we use circular linked list. Next I will explain advantages of network model. When compared to hierarchical model, in network model, we can access data very fast because there is more than one path in order to reach to particular node. So we can access data in many ways. There are multiple paths for particular node and there are multiple ways in order to access data. And next advantage is, if we make any changes to parent node, then it will affect on child node. Next I will explain disadvantages of network model. First disadvantage is a single child node can contain multiple parents. Relationship is very complex. So in order to design network model, there is lot of knowledge required. So network model is complex. And if you want to perform any changes to data which is present in network model, it is very complex. If you want to perform any operations like updation, deletion, insertion of data in network model, then it is very complex. Next I will explain entity relationship model. Guys, shortly we call this entity relationship model as ER model. Entity relationship model or simply ER model is a high level data model diagram. Guys, this ER model is nothing but it is simply a data model diagram. In this model, we represent the real world problems in the pictorial form to make it easy for the stakeholders to understand. Guys, pictorial form is nothing but diagrammatic form. If we represent any problem in diagrammatic form, then employees working in the organization can easily understand. If any developer who want to develop any database, then simply by seeing ER diagram, he can understand. This ER model is simply a ER diagram. This ER model contains three components. They are entities, attributes and relationship. Entity is a real world thing. It can be a person or place or even a concept. For example, if you consider in school there can be teachers, students, course, building, department, so on. All these are considered as entities. Next one is attributes. Whatever the properties that this entities contains, we call these properties as attributes. For example, if you consider teacher is entity, this teacher entity may contains various attributes like teacher name, teacher salary, teacher age, teacher ID and so on. So we call all these as attributes. And third one is relationship. Relationship tells us that how two entities are related. For example, there is one entity, that entity is teacher and next entity is department. Now what is relationship between this teacher and department? As we know, teacher works for department, so there is works for relationship between teacher and department. Guys, I will give an example. For example, this is student table. Student table contains student name, student roll number and section. Now this table name student is considered as entity and we will represent entity in rectangle. So inside rectangle I written student. And similarly, student table contains three columns. They are student name, roll number and section. Now we call these column names as attributes and we need to represent attributes in ellipse. This is another example. For example, there are two entities. One entity is teacher and next entity is department. This teacher entity contains attributes like teacher name, teacher ID, mobile number, age and salary. And similarly, department entity contains attributes like department ID and department name. As you know, teacher works for department. So I am establishing work for relationship between teacher and department. And we need to represent relationship in dramas. This is simple ER model where we call this teacher name and department as entities and teacher name, teacher ID, mobile number, age, salary, department ID and department name. All these are attributes and this works for is relationship. These are features of ER model. First feature is graphical representation for better understanding. We will represent ER model in diagrammatic format which is easy to understand. So it can be used by the developers to communicate with the stakeholders. For example, one person came to me and he asked to design one database. Then if we show ER model, then he can easily understand. And next feature is ER diagram. ER diagram is used as a visual tool for representing the model. Before constructing house, builder will give us model. So by seeing that model, we can easily understand how our house will look like after construction. In same way, before designing database, once if we check ER model, then we can easily understand how our database will look like after implementation. And next feature is database design. This model helps the database designers to build the database and is widely used in database design. Mainly we will use this ER model in database design. Next I will explain advantages of ER model. First one is simple. This ER model is very easy to build. If we know relationship between attributes and entities, then we can easily build ER model. And next advantage is effective communication tool. We can communicate to any person by using ER model. That is nothing but if any person see ER model, by seeing that ER model, he can easily understand how database will look like after implementation. So database designers will widely use this ER model. And next advantage is easy conversion to any model. For example, this is student ER model where the student is entity and the student name, roll number and section are attributes. Now we can easily convert this ER model into relation model. So we can easily convert ER model to any other models. This model maps well to the relation model and can be easily converted to relational model. I already said before, it is very easy to convert ER model to relation model by converting ER model to tables. And not only relational model, we can also convert ER model to any other models like network model, hierarchical model and so on. Next I will explain disadvantages of ER model. First one is no industry standard for notation. Guys, there is no guarantee that all employees working in industry can understand this ER model. For example, one person designed ER model, but another person may not understand this ER model. And next disadvantage is hidden information. Guys, this ER model is high level data diagram. High level data diagram is nothing but most of the information is hidden in ER model. These are disadvantages of ER model. Guys, this hierarchical model and network model are old data models. Nowadays we are not at all using these models. At present we are using relational model. So next I will explain what is relational model. Relational model is most widely used model. In this model, data is maintained in the form of two-dimensional table. All the information is stored in the form of rows and columns. The basic structure of relational model is tables. So the tables are also called as relations in relational model. Thus relational model is nothing but whatever the data that is stored in the form of tables, we call it as relational model. Tables are nothing but in rows and columns. Guys, we also call tables as relations because we will store only related information. For example, if you consider employee table, in employee table we will store only employee related data like employee name, employee ID and so on. Guys, this is simple example of student table. We also call this table as relation. This student table contains 3 columns. They are student name, roll number and section. We also call columns as fields. Both are same. This student table contains 2 rows. They are Sai, roll number 13 and section A, Raju, roll number 14 and section B. Guys, we also call rows as records or we also call it as tuples. All are same, don't get confused. Guys, there are 2 features of relational model. They are rows and columns. We also call rows as, similarly we also call columns as attributes or we also call columns as fields. Rows contains individual information like name, Sai, roll number 13 and section A. And these attributes are nothing but properties. For example, if you consider student table contains properties like student name, student roll number, student section, student age and so on. Attributes contains properties. Next I will explain advantages of relational model. First one is simple. When compared to network model and hierarchical model, this relational model is very simple. And next one is scalable. If you want to insert new column or if you want to insert new rows, then it is very easy. And next advantage is structural independency. You can make changes to database structure without changing the way to access the data. Guys, we can easily change structure of tables like we can insert new columns or we can insert new rows. Even if we insert new rows and new columns, it will not affect any data which is present in database. Still we can easily access our data. Next I will explain disadvantages of relational model. First disadvantage is hardware overheads. In database we will store a huge amount of data. So we need proper storage device. And also we need powerful hardware like high-end processors. Next one is bad design. This relational model is very easy to design. People those who are using database, they don't even know how data is stored in database. They simply access data. For example, I am student. Just I will check my marks in my college database. But I don't know how the data is stored in database. So person who is designing this database must be focused. Or else in future if database grows, database will become slow. But these two are only minor disadvantages. When compared to disadvantages, advantages are more in relational model. If we implement relational model correctly, then there will not be any problem. Next I will explain object-oriented data model. The object-oriented data model in DBMS is the data model where data is stored in the form of objects. Guys, in object-oriented data model, we will store data in the form of objects. I will give one example so that you can clearly understand what is this object-oriented data model. This model is used to represent real-world entities. For example, if you consider college management system, students, faculty, department, all these are considered as real-world entities. Thus, in object-oriented data model, we will store data and as well as data relationship in single entity, and we call that entity as object. In object-oriented data model, we can store pictures, audios, videos, and other type of data. Where we can't store this in relation model. In relation model also we can store audios and videos, but it is not recommended. So if you want to store audios or videos or pictures or any other data, then you can use object-oriented data model. Guys, this is simple example of object-oriented data model. Actually, the student and department are entities. But whereas in object-oriented data model, we call the student and department as objects. Each object contains both attributes and methods. Attributes are nothing but properties. Like student can contains name, roll number, phone number, permanent number, department number and so on. We call it as attributes. Methods are nothing but operations. What are the operations that student can perform? So students will get marks, students will get subjects, so on. So all these are operations. So we will represent it as methods. Similarly, department can contain attributes like department number, department name, department staff, department strength, and so on. Normally we will find department information. So we will use getInfo method. So object can contains both attributes and methods. Here in object-oriented data model, data and as well as data relationship is stored in single entity known as object. Here department number is common for student and department. So we can establish relationship between student and department. That is nothing but student will register in particular department. Next I will explain features of object-oriented data model. First feature is objects. In object-oriented data model, data is represented as object. Just remember this. Object is nothing but it is instance of class. Like we will show student information in student class and department information in department class. Like that we will show different information in different classes. And each object contains attributes and methods. So each object has its own set of attributes and methods. And next feature is encapsulation. Here we will write implementation details. And next one is inheritance. Object-oriented data model supports inheritance, which allows class to inherit attributes and methods of their parent class. For example, let us consider the student is parent class. Now I want to create subclass like CSC students. Now I can create this class by inheriting attributes and methods which are present in parent class. I can simply copy these attributes and methods. Next feature is polymorphism. Poly means many, morphism in forms, that means many forms. For example, there are different objects in different classes. Now we can adopt all those objects and we can represent all those objects in single class. Next I will explain advantages of object-oriented data model. First advantage is reusability. Object-oriented data model promotes code reusability through inheritance. Classes can be derived from existing classes, inheriting their attributes and methods. Inheritance is nothing but process of deriving child class from parent class. In order to create new class, we will adapt attributes and methods from parent class. Next advantage is modularity. For example, I want to design one complex system. So simply I can divide these complex systems into submodules. So it makes easy to maintain and update the system. And last advantage is flexibility. Guys, we can design various classes according to our requirement. Next I will explain disadvantages of object-oriented data model. Guys, it is very hard to design object-oriented data model and it is very complicated to use. And we need to spend lot of time and lot of money. So it is complex. And next one is performance. When compared to all other data models, object-oriented data model is slow. And next one is scalability. Scalability is nothing but capacity. For example, if we increase more objects in object-oriented data model, many problems will occur. Though there are many advantages, there are equal disadvantages in object-oriented data model. So based on your project, you need to choose object-oriented data model. Next I will explain object-relational model. The name itself says object-relational model. Object is nothing but object-oriented data model and relational is nothing but relation model. Object-oriented data model supports objects, classes, inheritance and so on. Similarly, in relational model, we will represent data in the form of tables. So by combining features of these two models, object-relational model was created. Guys, normally in order to create database, we need to use structured query language. But whereas in object-relational model, for example, if you consider Java, C++, Python, all these are object-oriented programming languages. By using this programming language itself, we can create database and we can manage database. We will represent data in the form of tables. Next, I will explain flat data model. In olden days when computer was first introduced, we used to store our data in flat files. Just inside file, we will create one table and we will store data. And there is no use of this model. Guys, it is not a relational model, but simply we will create one table inside file and we will store data. And for example, if any person want any information, then he need to read this entire table. So this flat data model is very slow and inefficient. Context data model is nothing but combination of all models. Whereas in associative data model, we will divide data into two parts. They are items and links. Guys, this flat data model, associative data model and context data model are not important. So you can ignore this. And last one is semi-structured data model. This semi-structured data model is a data model used in DBMS that allows for representation of data in a flexible, hierarchical and loosely structured manner. The name itself says semi-structured. We will not represent data in complete structured format. Instead, we will use semi-structured format. Unlike traditional relational data models, where data is organized in the form of tables with predefined columns and data types. Semi-structured data models allows for the storage of data with varying and evolving schema. Guys, I will give one example so that you can clearly understand what is semi-structured model. For example, if you consider relational model, in relational model we will show data in the form of tables. For example, I want to show information of 3 different students. One student name is Sai, rule number 21. So I will create name column and as well as rule number column. And I will insert name Sai and rule number 21. Similarly, for another student, I want to insert name Ravi, section A. So name column is already present, so I can write Ravi. And section column is not present in my table. So again I need to create section column and I need to write section A. And similarly, there is another student. The student name is Raju. This time I want to insert age 20. So again I need to create age column. Here I will insert name Raju and age 20. But in relational data model we need to create predefined columns. That is nothing but before inserting data, at first we need to create columns. If you want to show details of different individuals with different attribute names, then you can use semi-structured model. XML and JSON are examples of semi-structured model. For example, for one student I want to store name Sai and section A, and for another student I want to store name Ravi and rule number 21. So just I need to create student name Sai section A. Guys, in XML we will represent data in tags. Anything that is written in angle brackets is known as tag. So at first I open student tag. Inside student tag I written name tag. Inside name tag I written Sai. For every open tag there should be a closed tag. So I took a slash symbol. Similarly, I open section tag. I written A and I close the section tag and I close the student tag. Similarly, another student. So I open student tag. Inside student tag I written name Ravi and rule number 21. Similarly, I close this name tag, rule number tag and student tag. Another example of semi-structured model is JSON, where JSON stands for JavaScript Object Notation. In this we will represent data in the form of classes. So where name Sai section A, all are strings. So take quotations. And similarly, another student name Ravi, rule number 21, where 21 is integer. So there is no need of taking quotations, just write 21. This is semi-structured model. These are features of semi-structured model. First feature is flexibility. Though there are various types of data, we can show data in semi-structured data model. For one person there is section, for one person there is rule number, and for one person there is age. Even though data is different, we can show data in semi-structured model. Next one is hierarchical structure. If you consider previous example, XML and JSON, we will show data in hierarchical format like at first student, inside name, section, so on. This is in hierarchical format. And third feature is loosely structured. Guys, we will not show data in completely structured format. Instead, we will show data in semi-structured format. So which is easy to handle data. And next one is no fixed schema. Schema is nothing but structured representation of data is known as schema. Semi-structured data model does not require any predefined schema. Any predefined structure is not required. So based on data, we can create structure. Next, I will explain advantages of semi-structured model. First advantage is flexibility. Based on data, we can change structures. Even though there is complex data, we can handle the data. So it is flexible. And next advantage is scalability. Semi-structured data model has ability to handle complex data sets. And third advantage is easy integration. As data is stored in semi-structured format, we can easily integrate data. Integrate is nothing but combining data is very easy. And last advantage is reduced development time. As data is not stored in structured format like tables, simply we will store data in semi-structured format. So it is very easy to develop semi-structured model. Guys, there are two disadvantages in semi-structured model. First disadvantage is query processing. As different type of data is stored in semi-structured model, it is very complex to write queries. And next disadvantage is storage space. It will occupy much space. Guys, in exam you may also get separate questions like explain hierarchical model, advantages, features of hierarchical model, and so on. Next I will explain what is schema and instance in DBMS. At first I will explain what is schema. The design of the database is called as schema. Schema tells us about the structural view of the database. It gives us an overall description of the database. Guys, schema is nothing but design of database. That is nothing but if we represent overall database in structured format, then we call it as schema. The schema will provide overall description of the database. I will give one example so that you can clearly understand what is schema. For example, let us consider my database name is my database. My database contains total 3 tables. One table is employee table, one table is department table, and one table is project table. Employee table contains total 6 columns. They are name, job title, phone number, salary, department ID and project ID. And similarly, department table contains 2 columns. They are department ID and department name. And project table contains project ID and project name columns. As we know, employees works in department. So we can establish relationship between this employee table and department table. Department ID column is common for these both tables. So we can establish relationship by connecting these 2 columns. Now I will connect these 2 columns, and similarly every employee works on particular project. So we can establish relationship between this employee table and project table. Project ID column is common for these both tables. So we can establish relationship by connecting these 2 columns. Now this entire structure is known as schema. How many tables that are present inside my database? The table names. And how many columns that are present inside particular table? That column names. And relationship between these tables. This entire structure is considered as schema. Guys, schema will represent only structure of the database, but it will not display actual data which is present in database. For example, inside employee table there is record name Sai, manager, contact number 35,000 and so on. But it will not display this record. It will just display structure of the database, but it does not show actual data. Guys, we will represent this structure by using schema diagram. I will draw schema diagram for this database. Guys, this is schema diagram for this database. Total there are 3 tables: employee, department and project. Guys, in this diagram we call table name as entities, and where this name, job title, phone number, salary, department ID, project ID, all these are column names. But in this diagram we call these column names as attributes. Attributes are nothing but properties, where this table name is entity and these column names are attributes. And I am establishing relationship between this employee table and department table, and similarly employee table and project table. Guys, this is entire schema diagram. Schema diagram contains only table name and column names and relationship between tables. We call it as schema. A database schema defines how the data is organized using the schema diagram. We will represent schema by using schema diagram. A schema diagram is a diagram which contains entities. Entities are nothing but table names, and the attributes. Attributes are nothing but column names. That will define the schema. A schema diagram only shows us the database design. It does not show the actual data of database. As I already said before, schema will represent only structure of database, but it will not show actual data. Schema can be a single table, or it can have more than one table which is related. In database, if there is only single table, then we call that single table as schema. For example, if there are multiple tables which are related, then we call that multiple tables as schema. Next I will explain what is instance. Guys, we also call instance as extension, or we also call it as database state. Instance is a collection of information that is stored in a database at particular moment is called an instance of database. Guys, instance is nothing but, for example, I open my database. Inside my database there is employee table. Employee table contains employee ID, that is ID1, name Sai and salary 5000, and similarly ID2, name Ramesh and salary 6000. Whenever I open my database, at particular point of time, whatever the information that is present inside my database, we call that information as instance. For example, at 9 AM I open this database. This database contains this information. We call it as instance. I close this database and again at 9:30 I open this database. Now whenever I open this database at 9:30, there are 3 records inside this table. Now we call it as instance. At particular point of time, whatever the information that is present inside my database, we call that information as instance. Guys, in exam you may get question like explain difference between schema and instance. Schema will just provide description of database like table name, column names and so on. And whereas instance will provide snapshot of database at particular point of time. We will not change schema frequently. Only whenever we want to insert new columns or only whenever we insert new tables, we will change structure of schema, but we will not change schema frequently. So schema rarely changes, and whereas frequently we will keep on inserting, updating and modifying records. So instance changes frequently. Here name, rule number and section are examples of schema, and whereas Sai 21 and section A are examples of instance. Next I will explain what is data abstraction, and then I will explain levels of abstraction for DBMS. We also call this levels of abstraction as 3 levels of the schema, or we also call it as 3-tier schema architecture. And next I will explain data independency and what is physical data independency and logical data independency. At first I will explain what is data abstraction. Data abstraction is a process of hiding unwanted or irrelevant details from the end user. The developers keep away the complex data from the user and remove the complications so that the user can comfortably access data in the database and can only access data that he wants, which is done with the help of data abstraction. Guys, I will give one example so that you can clearly understand what is data abstraction. For example, let us consider college database. Normally, student will access college database and as well as faculty will access college database. Whenever student opens this college database, this database will display only student information, like it will display student course, student marks, attendance and so on. But it will not display faculty information to student, and also it will not display how data is stored in database, what is the code that programmer written in order to develop this database, and also it will not display how much memory database contains. Just it will display only student information. It will not display all other information. And similarly, whenever faculty opens this college database, this database will display only faculty information like faculty attendance, faculty salary and so on. But it will not display student information to this faculty, and also it will not display how data is stored in database, how much memory this database contains, and what is the code that programmer written to develop this database. It will not display any other information. Just it will display only faculty information. So developers who develop database will keep avoid complex data from the user. So users can comfortably access only data that he want, and it can be achieved by using data abstraction. So with the help of database abstraction, developer will hide unwanted information from the user and he will display only related information. So user can easily access data without any pressure, and system also works efficiently. For example, if we display unwanted data to user, then our database will consume lot of memory and system may slow down. So if we display only related information, system will work efficiently. Developers use levels of abstraction in order to hide unwanted information from the user. These levels of abstraction simplify database design. If you use levels of abstraction, then it is very easy to design database. Guys, I will explain these levels of abstraction in detail. Guys, we also call levels of abstraction as 3 levels of the schema, or we can also call it as 3-tier schema architecture. In exam, they may ask question in different ways, so don't get confused. Guys, we also call levels of abstraction as 3 levels of the schema. Why we call it as 3 levels of the schema? Schema is nothing but structure of database. In order to achieve data abstraction, we need to divide our database structure into 3 levels. So we call it as 3 levels of the schema. Schema is nothing but structure of database. These are 3 levels. First one is physical level. We also call this physical level as internal level. And second one is logical level. We also call this logical level as conceptual level. Third one is view level. We also call this view level as external level. I will explain all these levels in detail. Guys, this is simple diagram of levels of abstraction. In data abstraction, first level is physical level. The name itself says physical level, where we need to store our database physically. Either we need to store our database in local disk D or local disk E, in which location we need to store our database. In software companies, there is one person called database administrator. The main duty of this database administrator is to manage database, like where we need to store our data. Like we need to store our data in local disk D or local disk C, in which location we need to store our data, and how much memory we need to give to our database, and how to arrange data, how to manage data, and what are the methods that we need to define in order to access data in the database. Like user should access data by writing SQL queries, or directly user should access data by using graphical user interface, like just clicking on the button user can access data in the database. Everything is decided by database administrator. This is physical level. It will be very complex in order to display all this information to end user. So physical level is very complex. That is why we will hide physical level from end user. This is all about physical level, and next one is logical level. For example, let us consider I am college owner. Now what I will do is I will go to one software company in order to create college database. Whenever I go to software company, at first I need to meet database designers and I need to explain my requirements to these database designers. Whenever I explain my requirements to these database designers will create one data model. Data model is nothing but they will represent my database in diagrammatic format. We also call these database designers as data architect. After creating data model, these database designers will submit this data model diagram to database developers. Now these developers will start creating tables, columns and so on. These database designers and as well as database developers are involved in this logical level. Creating data model is nothing but conceptual schema. Schema is nothing but structure. We also call conceptual schema as logical schema. And creating tables, columns, so on is known as physical schema. In software companies, there are database designers, or we also call them as database architects. These employees are responsible for understanding our requirements and then creating conceptual schema. That is nothing but they will create one data model. The data model contains entities, attributes and relationships. Entities are nothing but table names and attributes are nothing but column names. They will represent all this in diagrammatic format. After creating data model, these database designers will submit this data model to database developers. Now these database developers will translate our data model into physical schema. That is nothing but they will create tables, columns and so on. This is all about logical level. And next level is view level. Database will show different views for different users. For example, let us consider college database. In college database, there will be faculty and as well as student. Now database will display student information to student and faculty information to faculty. It will show only related information to the user and it will hide unwanted information. This is view level. These are three levels of data abstraction. For users, database will not show logical information and physical information. And similarly, people who are working in physical level, they need only information regarding this physical level, but they don't want logical level information or view level information. And similarly, people who are working in logical level, they don't want any physical information or view information. This is known as data abstraction. Next, I will explain features of data abstraction. First feature is multiple levels. As we know, data abstraction contains 3 levels. So different users will view database system at different levels. And next feature is clear separation. Database will display separate data for different users. And third feature is data independency. Changes made at one level does not affect other levels. Guys, this question is very important. I will explain in detail about this data independency. Data independency is nothing but changes made at one level does not affect other level. For example, database administrator increased the database size from 100 GB to 200 GB. Even though database administrator increase size, it will not affect logical level or view level. So changes made at one level does not affect other levels. This is meaning of data independency. One level will not depend on other level. And fourth feature is transparency. Meaning of transparency is clearness. As database will show only related information, data will be very clear. This is meaning of transparency. Next, I will explain advantages of data abstraction. First advantage is it will display only related data. And second advantage is it provides security. For example, if you consider student, database will display only student information to student. And similarly, database will display only faculty information to faculty. But it will not display faculty details to student. So data will be secure. And next one is system works efficiently. In database, we will store only related information. So it will not occupy much memory and system will be fast. These are advantages of data abstraction. Guys, by data abstraction, we can achieve data independency. Next, I will explain what is data independency. The ability to modify the schema definition of a DBMS at one level without affecting the schema definition of next higher levels is called data independency. Schema is nothing but logical structure of database. Guys, data independency is nothing but modifications done at one level will not affect other levels. For example, let us consider in physical level there will be a data administrator. What he will do is, he will increase database size from 100 GB to 200 GB. Even though if this person increase data from 100 GB to 200 GB, it will not affect remaining levels. That is, it will not change structure of database, it will not change columns and tables which are present in logical level, and similarly, person can easily view data without any change. So modification done at one level will not affect other levels. This is meaning of data independency. The main goal of data independency is to make data independent of the user. Modification done by one user at particular level should not affect users in another levels. So data independence is one of the important characteristics in DBMS. As we know, in database we will store complete data in one location in different tables, and we will update huge amount of data in database daily, and we need to satisfy user requirements. So that is the reason why we need this multi-layer architecture. In multi-layer architecture, modifications done at one level will not affect other levels. And there are two types of data independency. One is physical data independency and next one is logical data independency. First one is physical data independency. The name itself says physical data independency. That means changes made at physical level will not affect logical level and view level. For example, database administrator bought one new hard disk with new technology. Now what he will do is, you will copy complete data which is present in database to this new hard disk. So even though if we copy this data to new hard disk, it will not affect logical level or view level. That is, still users can view data which is present in database, and it will not change structure of database, like it will not change tables, columns and so on. So it will not affect logical level or view level. And another example is change the location of the database from one drive to another drive. For example, database administrator transfer this database from local disk D to local disk E, even though there is no problem. And third example is changing the database files organization. In database there will be multiple files. Let us consider these are files. Now what database administrator will do is, he will move this file from second position to first position. So even though if we change database file organization, there is no problem. It will not affect logical level or view level. And another example is changing from one data structure to another. For example, there is one table in database. Now this database administrator will divide this table into two parts. Even though if we divide database table into two parts, there is no problem. So changing structure in physical level will not affect other levels. This is all about physical data independency. Next one is logical data independency. The name itself says logical data independency. That means changes made in logical level will not affect view level or physical level. For example, as we know, in logical level, database designers and as well as database programmers are involved. In college database, there will be student table and as well as employee table. Now this database developer will create one more table with name admin employees. Even though if we change structure of the database, it will not affect physical level and it will not affect view level. That is, still users can view his data. For example, if student is accessing data, even though if database developer insert new table in database, it will not affect. Still student can view his data. Whenever any changes made in logical level, like inserting table, inserting new column inside table, or merging two records, or breaking existing record into two parts, if we perform all these operations, it will not affect view level and logical level. There is no need of performing any modifications in physical level. Even though if we perform changes at physical level, like database administrator transfer database from one hard disk to another hard disk, even though user can access data, there is no problem. Just by writing SQL queries, user can easily access data. For example, if you perform any changes in logical level, like adding new columns or deleting new columns and so on, then it will be difficult for users to retrieve data. For example, database programmer removed this phone number column in student table. Student will write SQL query in order to check his phone number. But here programmer removed this column, so he will not get that information. So if we change structure at logical level, retrieving data is very difficult. Guys, here attributes are nothing but column names. Next I will explain one tier, two tier and three tier architecture in DBMS. And also I will explain difference between two tier architecture and three tier architecture. Guys, architecture is nothing but structured design. For example, I want to construct house, so I will go to builder. Whenever I go to builder, he will show me some designs of house. So based on my requirement, I will choose one design. Here my house construction depends on house architecture. Similarly, if you want to design any DBMS software, here your DBMS design depends upon the DBMS architecture. The DBMS design depends upon its architecture. But how to design this DBMS architecture? Here your database architecture design depends upon the how users communicate with database in order to get their request done. Guys, there are so many ways user will interact with database. For example, guys, some users will directly communicate with database software, but some users will not communicate with database software directly. Instead, they will use one software in order to communicate with database software. Like that, there are so many ways users will communicate with database. So DBMS architecture depends on how users communicate with database to get their request done. There are three most commonly used database management system architectures. They are one tier architecture, two tier architecture and three tier architecture. Before knowing this one tier, two tier and three tier architecture, at first you need to know what is client server architecture. Person who will send request is known as client and server will give response to him. For example, let us consider I open Amazon website in order to purchase mobile. After I entered into Amazon website, I will type mobiles below 25,000. Whenever I type mobiles below 25,000 and click enter, it will transfer my request to Amazon server. It is Amazon server. This Amazon server contains information about all products. Whenever I send request to Amazon server, this Amazon server will display all mobiles below 25,000. Here I am sending request, so I am client, and whereas server will provide response. Guys, each and every software company contains server. Inside server there will be a database. in this database complete data is stored. For example, if you consider Amazon, complete Amazon product details are stored in this Amazon database. For example, if you consider Facebook, Facebook also contains servers. In that server, there will be a database. Inside database, complete Facebook information is stored. For example, if I upload any image, that image is stored in Facebook database. For example, if I share any post, that post is stored in Facebook database. This is simple example of client and server architecture. The basic client server architecture is used to deal with a large number of PCs, web servers, database servers that are connected with network. Network is nothing but internet. For example, if you consider Amazon, Amazon is simple example of client server architecture, and there are multiple users who will use Amazon at a time. So this client server architecture deals with large number of systems, and we will access Amazon by using internet. So this large number of PCs, web servers all are connected with internet. Guys, these 2-tier and 3-tier architectures are client server architectures. At first I will explain what is 1-tier architecture. Guys, this is simple structure of 1-tier architecture. In 1-tier architecture, database software is present in user's computer itself. For example, in my college lab, I want to practice DBMS. So I will go to lab and I will open system. And inside that system, I will open one DBMS software like MySQL. Inside MySQL, I will create some tables. Here I am using DBMS software in my computer itself. So it is simple example of 1-tier architecture. In 1-tier architecture, user will use database management system software in his computer itself. In this architecture, the database is directly available to the user. It means the user can directly sit on the DBMS and use it. For example, if I create table, it is directly stored in database. So any changes done here will be directly done on database itself. Normally this 1-tier architecture is used by programmers in order to develop local applications. For example, I am programmer. Now I want to create one small software. So for that purpose I need database. So inside my system I will create database. So this 1-tier architecture is used for local application development where programmers can directly communicate with database for quick response. Here programmers will directly communicate with database for quick response. Next I will explain 2-tier architecture. Guys, whereas in 1-tier architecture, user will directly interact with database management system software like MySQL. But whereas in 2-tier architecture, user will not interact with database software directly. Instead, he will use one software in order to interact with database software. For example, I went to railway station in order to purchase ticket. So whenever I go to railway station, that person in counter will open one software. Now inside the software, he will enter all my details. Whenever this person enters all my details and click on submit, these details are stored in railway database. Here user is not interacting with database software directly. Instead, he is using one application in order to interact with database. This is simple structure of 2-tier architecture. Here person is using railway application in order to interact with railway database. Here this user, by using application, he will send request. So this user and application are considered as client, and whereas railway database will provide response. So this database software is considered as server. All this user information is stored in railway database. Guys, in this 2-tier architecture, not only single user, there can be multiple users. For example, at a time 10 members will purchase ticket. So multiple users will interact with database. The 2-tier architecture is same as basic client server architecture. In 2-tier architecture, applications on the client side can directly communicate with database on server side. Guys, applications are nothing but softwares. By using these softwares, user can directly communicate with database. The servers will accept our request and they will provide response and so on. Guys, DBMS is nothing but it is a software like MySQL. To communicate with DBMS, client side application will establish connection with server side. Here client side application will establish connection with server. Purchasing ticket in railway station is simple example of 2-tier architecture. Next I will explain what is 3-tier architecture. Guys, whereas in 2-tier architecture, by using software, user can directly interact with database. But whereas in 3-tier architecture, user cannot interact with database directly because there is software present in client side and also there is software at server side. Whenever I send any request by using this application, my request is sent to server side software and the server side software will perform operations on my database. Guys, web-based applications are simple example of 3-tier architecture. For example, I open Amazon application in order to purchase mobile. So at first what I will do is, I will search like mobiles below 20,000. Whenever I enter mobiles below 20,000 and click enter, at first my request is transferred to Amazon application which is present on server side. It will not transfer my request directly to Amazon database. Instead, at first my request is transferred to Amazon application which is present on server side. Now this server side application will collect complete details about mobiles which are below 20,000. and it will display to user. This is simple example of 3-tier architecture where user and user application, server application and database are involved in 3-tier architecture. So 3-tier architecture is used in web-based applications like Amazon, Facebook and so on. Guys, in 3-tier architecture, user will not interact with database directly. Instead, he will interact with server-side application. So whatever the data that is present inside database will be secure. In 3-tier architecture, client cannot directly communicate with server. Guys, database will be present in server. So directly you can also call server instead of database. The application on the client end interacts with application server, which further communicates with database system. The server side application will communicate with database. End user has no idea about the existence of database beyond the application server. Guys, this user don't know anything about this database. He just know about this application server, that's it. And database also has no idea about any other user beyond the application. This database also don't know about user, because there is server application between this user and database. That is why they don't know each other. Next, I will explain difference between 2-tier architecture and 3-tier architecture. 2-tier architecture is a client-server architecture. Client will use software and directly communicate with database. So we call it as client-server architecture. Guys, many users will interact with 2-tier architecture and as well as 3-tier architecture. And whereas 3-tier architecture is web-based application, for example Amazon. This 2-tier architecture is easy to build and maintain. And whereas 3-tier architecture is complex to build and maintain. It runs slower and it runs faster because it is web-based application. So it will be very fast when compared to 2-tier architecture. As user will directly interact with database, this 2-tier architecture is not secure. And whereas in 3-tier architecture, user will not interact with database directly. So data is secured in 3-tier architecture. In 2-tier architecture, if users increases, then performance decreases. And whereas 3-tier architecture runs on internet. So even though users increases, there will not be any problem with performance. Example of 2-tier architecture is railway reservation system. Example of 3-tier architecture is Amazon.in, Facebook, so on. Next, I will explain database system architecture in DBMS. Guys, database system is nothing but it is a software. And whereas database system architecture means overall structure of this database software. Database system architecture refers to the overall structure and organization of database management system. This database system architecture will represent structure of DBMS and as well as organization of DBMS. Guys, organization of DBMS is nothing but how all files are arranged in database management system software. So this architecture will represent both structure and as well as organization of DBMS. It involves understanding how different components of DBMS work together. For example, I am using this database management system software. In this software, there is student database. Now I want to store information like name Sai, roll number 21 and section A. I want to store this record in student database. So I need to send request. So whenever I send any request, my information is not directly stored in the student database. Instead, at first my information is sent to this component 1 and again my information is sent to this component 2 and at last my information is stored in the student database. So database system architecture contains various components that works together. This database system contains two functional components. They are storage manager and query processor components. Before I explain the architecture of this database system, first you need to know different types of users that use this database system. There are 4 types of users that use this database system software. They are naive users, application programmers, sophisticated users and database administrators. Naive users are unsophisticated users. That means these users don't have any knowledge on database. They don't write any code. Just by using some interfaces, they will interact with database. For example, if you consider Amazon application, people those are using Amazon application don't have any knowledge on database. For example, I am user. I want to purchase product. So I will enter all my details and then I will just click on this buy now button. So whenever I click on this buy now button, my entire information like my name, my address and what type of product I purchased and cost of that product, time, everything is stored in this Amazon database. That means I am not writing any code. Just I am using interface in order to access Amazon database. This buy now button is simple example of interface. So just by using interface like buttons, user can access database. So they will not write any code. So we call this Amazon users as naive users because they don't have any knowledge on database. Just by using interfaces, they will access database. Next users are application programmers. We also call application programmers as application developers. These application programmers are responsible for creating software applications that interact with the database. These application programmers will develop application programming interfaces to communicate with database. For example, if you consider buy now button, this buy now button is an interface. This interface is created by application programmers. So whenever user click on this buy now button, then his information must be stored in the database. So for that purpose, these application programmers will create buy now button, and as well as they will insert code inside this buy now button. So whenever user click on this button, particular action takes place, that is, data is stored in the database. So application programmers will develop application programming interfaces to communicate with database. Next users are sophisticated users. Whereas if you consider naive users are unsophisticated users. That means they don't have any knowledge on database. And whereas sophisticated users mean these users have knowledge on database. That means by using structured query language commands, they will directly interact with database. And last users are database administrators. In each and every software company, there will be a database administrator. The main duty of this database administrator is to maintain database system. This database administrator is responsible to ensure that database system is running smoothly, securely and efficiently. These are various responsibilities of database administrator. And the first one is database installation and configuration. Database administrator will install database software and he will configure it. That is nothing but he will provide settings to the database, like how to arrange files in database, security settings and etc. Guys, software company contains servers. So database administrator will install this database software on the servers. Next one is database backup and recovery. Backup is nothing but whatever the data that is present in my database, we need to store the data copies in multiple locations. So if we store our data copies in multiple locations, in case if any failure occurs, then we can easily restore our data. So recovery is nothing but restoring our data. In database software, automatic backup takes place. That is nothing but it will automatically store my data in multiple locations, which is very easy to recover in case of data loss. Database administrator also provides data security. That is nothing but he will set password to database. So only users having those password can access database. And also this database administrator will give various access control permissions. For example, for some users DBA will give read permission, and for some other users DBA will give write permission. If database administrator give only read permission, person cannot insert or update or delete data. Just he can read data. For example, if DBA give write permission, then this person can perform various operations on database, like he can insert data, he can modify data and he can delete data. DBA will give various types of access control permissions to various users. And fourth one is database performance tuning. Daily database administrator will check performance of database software, like he will check whether database is working correctly or not. And last one is database maintenance and upgrades. Database administrator will maintain database, and in case if there are any new updates, then he will install those updates. All these operations are performed by database administrator. These are various responsibilities of database administrator. Guys, in exam you may get separate question like who is DBA and explain role and responsibilities of DBA. You may get this question in exam. Now I will explain database system architecture. Total there are 4 types of users: naive users, application programmers, sophisticated user and database administrator. Naive users use application interfaces, and whereas application programmers will write application programs, and sophisticated users use query tools in order to write queries. Database administrator will use administration tools in order to define structure of database. Defining structure is nothing but creating database, creating tables and creating columns. Except inserting data, creating database, creating tables and columns comes under data definition. In order to define structure of database, this database administrator must write data definition language queries. Whenever database administrator writes data definition language commands, all these commands are handled by data definition language interpreter. This data definition language interpreter will process and execute commands which are written by database administrator. Database administrators will just create structure of database. That is nothing but creating database and creating tables inside database. And whereas the sophisticated users will insert data, insert tables, but also they will update data and they can also delete data. Inserting data, updating data and deleting data. All these operations are performed by sophisticated users. And in order to insert data or update data or delete data, these users must write data manipulation language queries. Sophisticated users, by using query tools, they will write DML queries. Not only sophisticated users, but also this database administrator. By using administration tools, he can also insert data, update data or delete data. So I am connecting. Whenever users write these DML queries, these DML queries are handled by DML compiler and organizer. This DML compiler will process and execute DML queries which are written by users. After processing and executing queries, this DML compiler will create one execution plan. This DML organizer will execute execution plan which is generated by DML compiler. So we also call this DML organizer as query executor. Guys, we already know what is compiler. Even in C programming we use compiler. Compiler is used to convert high level language code into machine understandable language. By using structured query language, that is by using SQL, we will write DML queries and DDL queries. And these queries are in high level language. So in order to convert these high level language queries into machine understandable language, we need DDL interpreter and DML compiler. This DML compiler and DDL interpreter, these both are used to convert high level language code into machine understandable language. And next users are application programmers. These application programmers will write application programs. Compiler will process and execute programs which are written by application programmers. I already explained Amazon application example. Whenever user click on buy now button, then his information is stored in the database. So in that application interface, code is written by application programmers. So after compiling this application program, that program is inserted in this interface. Whenever user click on buy now button, then his information is stored in the database. That is nothing but data manipulation. So in this code, data manipulation takes place. So I am linking this to data manipulation language queries. So this interface also contains data manipulation. So I am linking this to data manipulation language queries. Guys, this code is written by application programmers and this code is placed in interfaces. Now I will connect application program object code and as well as DML compiler and organizer. I will connect this both to query evaluation engine. Guys, this query evaluation engine is one of the important component in DBMS. This query evaluation engine will take requests from users and also it will provide response to users. It will perform various operations like first one is query processing and validation. This query evaluation engine will process queries and also it will validate queries. Validation is nothing but it will check whether queries written by user is correct or wrong. And next one is query optimization. This query evaluation engine will optimize queries written by users. Query optimization is done in order to efficiently and fastly retrieve data. And this query evaluation engine also contains execution plan in order to fast retrieval of data. And next one is concurrency control. Not only single user, if multiple users send requests at a time, then this query evaluation engine will provide response to multiple users at a time. And last one is result formatting and delivery. Guys, result formatting is nothing but, for example, there is student table in my database. I don't want details of complete students. I just want to see information of the students whose marks are greater than 30. So this query evaluation engine has capability to format my result based on my request. All these operations are performed by query evaluation engine. Guys, in exam you may get separate question like explain query evaluation engine. Then you can write this answer. Guys, this database system architecture contains two components. First one is query processor components and second one is storage manager components. All these are components in query processor. The main function of this query processor is to convert high level language queries into low level language operations. These high level language queries are written by using SQL. First functional component is query processor and second functional component is storage manager. The storage manager contains four important components. They are buffer manager, file manager, authorization and integrity manager, and transaction manager. All these are components of storage manager. All these are connected to query evaluation engine. Whenever user send any request, after evaluating those requests, based on user request, either that request is sent to this buffer manager or file manager or authorization and integrity manager, or that request is sent to transaction manager. I will explain these four storage manager components in detail, but before that, you need to know what is disk storage. Disk storage is nothing but physically where your data is stored, that location. For example, in DBMS software, I created one database. In the database, I created multiple tables. For example, now this database and as well as complete tables are stored in local disk C in one folder. For example, that folder name is mydb. In local disk C, in mydb folder, my entire data is stored. Now we call this location as disk storage. Disk storage is nothing but physically where your data is stored. That location is known as disk storage. Now this disk storage contains various kinds of data structures like data, indices, data dictionaries and statistical data. All these are various data structures in disk storage. This data will store your data itself, like your database, tables, everything is stored in data files. Next one is indices. Guys, for example, if you consider textbook, in first page of your textbook you can see index. There you can see various page numbers. By seeing that page numbers, you can easily find unit. So index numbers are used for fast access. Similarly, in database there will be multiple tables. So for each and every table you can give index numbers. If you give index numbers for all tables, then you can easily find particular table. If you give index numbers for tables, by using that index number, you can easily find that particular table. So indices are nothing but index numbers. These indices will provide faster access. And next one is data dictionary. This data dictionary will store metadata. Metadata is nothing but it will store data about data. For example, in college database, there are multiple tables like staff table, students table, admins tables and so on. Now this data dictionary contains one separate table. The table contains various information like names of all tables in database and names of all columns in tables, how many records that are present in each table, size of each table and who created that table, which users has read permission and which users has write permission, who are authorized users. When last modification is done on particular table, all this information is stored in data dictionary. So data dictionary is nothing but it will store data about data. And last one is statistical data. This statistical data will store statistical information like how many records are present in each table. This is all about disk storage. These are 4 storage manager components. I will explain each of them by giving example. First one is buffer manager. Normally my data is stored in hard disk. Whenever user send any request, sometimes some data must be stored in RAM for faster access. So what this buffer manager will do is, whenever user send any request, this buffer manager will collect information from hard disk and this buffer manager will store information in RAM in order to give faster response to users. This is use of buffer manager. So in order to collect information, this buffer manager is connected to this data and as well as indices in order to collect information. Next one is file manager. For example, I want information of student whose roll number is 20. Whenever I write that particular query, this query evaluation engine will evaluate that query and it will send that query to file manager. Now this file manager will collect information from this disk storage and then it will provide response to users. So this file manager is connected to this data and as well as indices. By using these index numbers and data, this file manager will provide faster response to users. This buffer manager and file manager both are connected to data and indices in order to provide faster response to users. And third one is authorization and integrity manager. For example, I am user. Now I want to insert data in student table. Like I want to insert name Sai, roll number 21 and section A. Inserting data is nothing but in order to insert data, I need to write data manipulation language queries. Guys, all users cannot insert data in database. Only person having write permission can insert data. So this DML compiler will check whether that particular user has write permission or not. Only if that person has write permission, then it will allow to insert data. Whether that user has write permission or not, that information is stored in data dictionary. So this DML compiler will check information from data dictionary. So I am connecting this DML compiler and organizer to data dictionary. Authorization and integrity manager. The name itself says authorization. Person who has authority to insert data can insert data. So I am connecting this authorization and integrity manager to data dictionary. Guys, integrity manager is nothing but integrity constraints. Integrity constraints are nothing but rules. If any column contains rules, that rules are handled by integrity manager. For example, in student table for roll number column, I applied primary key. Whenever I apply primary key to this roll number column, then this roll number column will not accept null values. For example, one user want to insert data like name Ramesh and rule number he want to give null value. So integrity manager will verify his request and immediately it will give response like rule number can't be null. Whereas authorization manager will check whether that user is authorized person or not, and whereas integrity manager will check integrity constraints. Integrity constraints are nothing but rules, and statistical data is nothing but it will store information about how many records that are present in particular table. So this statistical data is also connected to this DML compiler. And last one is transaction manager. Even if any system failure occurs, whatever the data that is present in database will be correct. This is because of transaction manager. Transaction manager ensures that data will be correct in database even in case of system failure. Even multiple users send requests at a time, all those users will get correct response. This is because of transaction manager. Transaction manager will execute multiple queries at a time without any problem. This is all about database system architecture. Guys, this query processor components and as well as storage manager components. These two are important. The storage manager acts as middle layer between query processor and disk storage. The storage manager takes request from user and then it will provide response to users. Guys, in exam you may get separate question like explain query processor components or explain storage manager components. Then you need to explain all these components. Next I will explain 6 steps of database design process in DBMS. Guys, total there are 6 steps in database design process, and main aim of this database design process is to develop efficient and high quality database. Once we have solid design, then we can easily develop database. In software company there is database architect and database administrator. The main duty of this database architect and database administrator is to design a database. Designing a database is nothing but they will draw ER diagrams. By seeing that ER diagrams, database developer can easily develop database. Guys, we also call this database architect as database designer. They both are responsible for management and control of overall database design process. Guys, total there are 6 steps in database design process. I will explain each of them in detail. Step 1 is requirement collection and analysis phase. Guys, before designing any database, at first we need to gather requirements. For example, let us consider one college principal came to software company in order to design college database. So at first we need to collect requirements from him. Like how many tables he want, what are frequently visiting tables, what are the relationship between tables and so on. At first we need to collect all this information. So in this phase, at first we need to interview users and then gather requirements. After that we need to document those requirements. We need to write all these requirements in document. Actually this requirement collection and analysis phase takes a lot of time, but it plays very important role in success of database. The outcomes of this phase is a document that contains the user specifications. Guys, this requirement collection and analysis phase is nothing but we need to document all users requirements. And second step is conceptual design. After gathering all users requirement, in software company there is database designer. The main duty of this database designer is to design ER diagrams. After collecting all users requirement, he will start designing ER diagrams. And step 3 is logical design phase. In logical design phase, by seeing these ER diagrams, this database developer will start designing relational model. That is nothing but he will start creating tables, establishing relationship between tables and so on. And fourth phase is physical design phase. In physical design phase, we will take decision about database server. Like in which location we need to store our database server, and also in physical design phase, we will perform optimization techniques. For example, let us consider database developer develop 10 tables. We will give index number for each table, so that by using this index number, we can easily access tables, which improves our database performance. And step 5 is implementation and loading phase. Actual implementation takes place in this phase. Whatever the tables that this database designer developed, we'll start inserting data inside the tables, and also we will execute queries. And last phase is testing and evaluation phase. In testing and evaluation phase, we will check whether the database is working correctly or not. Guys, this requirement collection and analysis phase, conceptual design phase and logical design phase, these 3 phases are related to ER model. These 3 phases are relevant to ER model. Next I will explain ER model topic in DBMS. I will explain what is ER model, and then I will explain what is an entity, types of entities, attributes, types of attributes, relationship and types of relationships. what is entity set, attribute set and relationship set. At first I will explain what is ER model. In ER model, E stands for entity and R stands for relationship. Guys, this ER model is nothing but it is simply a diagram. I will give one simple real life example. For example, I want to construct house. So I will go to builder. Whenever I go to builder, that builder will collect all my requirements like how many rooms I want, size of each room and where to locate hall, where to locate kitchen. This builder will collect all my requirements. After collecting all my requirements, he will draw one diagram and then he will show me how my house will look like after construction. By seeing the diagram, if I say OK, then this builder will start actual construction. So in same way, for example, I am college owner. I want to construct one database for my college. So I will go to software company. In each and every software company, there will be a database designer. The main duty of this database designer is to draw ER diagrams. So this database designer will collect all my requirements and then he will design one ER diagram. After designing ER diagram, this database designer will submit this ER diagram to database developer. Then by seeing this ER diagram, this database developer will start developing actual database. For example, this is my simple ER diagram which is created by database designer like student. Guys, this student is an entity. We will represent entity in rectangle. For example, students contain some properties like name, rule number and section, and we call these properties as attributes, and we will represent attributes in ellipse. For example, this is simple diagram which is designed by database designer. By seeing this diagram, this database developer will design one table like, guys, entity is nothing but table. So this database developer will create student table. Guys, attributes are nothing but columns. So total there are 3 columns. So one column is name, next column is rule number and next column is section. Guys, this is simple diagram which is designed by database designer. Then by seeing this diagram, database developer will create actual table in database software. This is simple definition of ER model. ER diagrams are used to represent the ER model in a database, which makes them easy to be converted into relations. ER model is nothing but it is simply a ER diagram. And by seeing this diagram, we can easily create tables. We also call tables as relations. People those who don't have any knowledge can also design ER diagrams. People those who don't have any knowledge on database is known as naive users. Even naive users can design these ER diagrams. These are various symbols that we use in ER model. On the first one is rectangle. Rectangle is used to represent entities. Entities are nothing but table names. And next one is ellipse. By using ellipse, we can represent attribute. Attributes are nothing but column names. If you want to establish relationship between two entities, then we need to use this diamond symbol. Diamond symbol is used to represent relationship. And next one is line. We can connect all this by using line. Double ellipse is used to represent multi-valued attributes. I will give examples. And next one is double rectangle. This double rectangle is used to represent weak entity. These are 3 components in ER model. And the first one is entity. Guys, entity is nothing but table name. Guys, entity is nothing but it is an object or thing that exists in real world. For example, car. We can create car table. We can create pen table. We can create student table. We can create faculty table and so on. So this car, pen, students all are entities. And we will represent entities by using rectangle. And there are 2 types of entities. One is tangible entity and next one is intangible entity. Physical object which we can touch or see is known as tangible entity. For example, if you consider mobile, we can touch mobile phone and as well as we can see mobile phone. And if you consider students, we can touch students and also we can see students. We can touch and see cars, bikes, so on. So objects which we can touch or see is known as tangible entity. And next one is intangible entity. Intangible entity means objects which we cannot touch or see. For example, if you consider bank account entity, we cannot touch this bank account because it is present in computer. So objects which we cannot touch physically is known as intangible entity. For example, bank account. Entities are of 2 types. They are strong entity and weak entity. Entities that contains primary key is known as strong entity. Entity is nothing but table name. For example, I created student entity. This student entity contains attributes like name, rule number, section and age. Attributes are nothing but column names. And we need to represent attributes in ellipse. So inside ellipse, I written name, rule number, section, age. For example, if you consider rule number, we cannot give same rule number for 2 different students. So definitely we need to give different rule numbers for different students. So primary key must contain unique values and it will not accept null values. Null is nothing but empty. So definitely we need to give rule number for each and every student and it will not accept null values. Null is nothing but empty value. and we will represent primary key attribute with underline symbol. So I am using underline symbol. So if any entity contains primary key attribute, then we call it as strong entity. An entity that does not contain primary key attribute is known as weak entity. If you consider this example there is no primary key attribute. So in this student entity, there is no primary key attribute. So we call this student entity as weak entity. And we will represent weak entity in double rectangle. So inside double rectangle I written student. Next I will explain attributes and types of attributes. An attribute is a property or characteristics of an entity. Properties of an entity is known as attribute. Guys, attributes are nothing but column names. For example, if you consider student is an entity, this student can contain various attributes like name, roll number and date of birth. Not only 3, you can give any number of attributes, and one of the attribute is considered as primary key. Whenever you give primary key for any particular attribute, then this attribute will contain only unique values. You cannot give same values. For example, if you give name Sai, roll number 21 and date of birth 1997, for another student, for example Raju, here already I given roll number 21. So again you should not give roll number 21. So you need to give different values like 22 and next to 23 for another student and so on. And also this primary key attribute will not accept null values. For example, there is one student like Rajesh, date of birth for example 2000. And here I don't want to give roll number. So what I will do is I will just write null. But whenever you give primary key for any particular attribute, then it will not accept null values. So definitely you need to give any number, and we will represent attributes in ellipse. This is ellipse symbol. We need to write attributes inside ellipse. And whereas for entities we need to use rectangle. Entity is nothing but table name, attributes are nothing but column names. These are various types of attributes. I will explain each and every attribute by giving example. First one is simple attribute. Attribute that cannot be subdivided into another component is known as simple attribute. I will give an example. For example, there is student entity. In this student entity, there are some attributes like name, roll number and date of birth, and also there is address. If you observe these attributes, I am not subdividing this. Just I written name, roll number, date of birth, address. I am not subdividing. So we call it as simple attributes. And next one is composite attributes. Attributes that can be subdivided into another components is known as composite attributes. Same example. For example, if you consider name attribute, now I am subdividing this name attribute like first name and last name. I subdivided this name attribute into two components. They are first name and last name. So we call this name attribute as composite attribute. We cannot subdivide roll number and we cannot subdivide date of birth. But we can subdivide address like state, pin code, street and door number. So we call this address attribute as composite attributes. Attributes which we can subdivide into another components is known as composite attributes. And next one is single valued attribute. Attribute that contains only single values is known as single valued attribute. For example, if you consider roll number, we can give only one roll number to particular student. And for example, if you consider date of birth, we can only give one date of birth. This roll number attribute and date of birth attribute. These both are examples of single valued attributes. Next I will explain multi-valued attributes. Attribute that contains multiple values is known as multi-valued attribute. For example, if you consider mobile number, we can give multiple mobile numbers. And for example, if you consider Gmail ID, one student can contain multiple Gmail IDs. So this Gmail ID and mobile number, these both are examples of multi-valued attributes. That means we can give multiple values. And definitely we need to represent multi-valued attributes in double ellipse. So inside double ellipse, I need to write mobile number, and inside double ellipse, I need to write Gmail ID. And next one is derived attribute. Guys, for example, for student I given date of birth 1997, for example. And now I want to calculate age. If you want to calculate age of particular student, then definitely we need date of birth. Based on date of birth and present year, we can calculate age. So indirectly this age attribute depends on date of birth attribute. So if any attribute depends on another attribute, then we call that attribute as derived attribute. And we need to represent derived attribute in dotted ellipse. This is dotted ellipse. So this age attribute is derived attribute because this attribute depends on date of birth attribute. And last one is key attribute. Key attribute is nothing but primary key. For example, if you consider this roll number attribute, just I am giving underline. That means we call it as key attribute. Whenever you give primary key for any particular attribute, then definitely we need to give different roll numbers for different students. And also it will not accept null values. These are various types of attributes. Next I will explain what is relationship. A relationship represents the association between entities. For example, there is student entity and there is course entity. I want to establish relationship between these two entities. As we know, student will enroll in course. So I will connect these two entities by establishing enrolled in relationship. We will represent relationship in rhombus, or you can also call it as diamond symbol. For example, there is faculty entity and there is department entity. Faculty will work for department. So we can establish work for relationship. For example, there is customer entity and there is product entity. Now I want to establish relationship between this customer and product. As we know, customer will buy product. So I am establishing buys relationship. In this way, by using relationship, you can establish relationship between entities. These are various types of relationships. And the first one is unary relationship. The name itself says unary means one. If only single entity is participating in relationship, then we call it as unary relationship. For example, there is person entity. As we know, person will marry to person. So I am establishing married to relationship. So we call it as unary relationship. And next one is binary relationship. Binary means two. If two entities are participating in relationship, then we call it as binary relationship. These are examples. And next one is ternary relationship. Ternary means three. If three entities are participating in relationship, then we call it as ternary relationship. For example, student enrolled in course and as well as faculty enrolled in course. So this enrolled in relationship is ternary relationship. These are various types of relationships. Next I will explain what is entity set, attribute set and relationship set. Set is nothing but collection of elements. At first I will explain what is entity set. Entity is nothing but table name and we will represent entity using rectangle. So for example, this is student entity. If this student entity contains only single record, for example name Sai, rule number 21 and age 25. For example, if this entity contains only single record, then we call it as entity. For example, if this entity contains multiple records like name Shiva, roll number 22, age 26, Raju, roll number 23 and age 18. If this entity contains multiple records, then we call this entity as entity set. Entity set is nothing but collection of entities. This is one entity, this is one entity and this is one entity. So collection of entities is known as entity set. Next I will explain what is attribute set. For example, if you consider this name attribute, I am subdividing this name attribute into first name, middle name and last name. Now this name attribute contains set like first name, middle name and last name. So we call this name attribute as attribute set. Attribute set is nothing but collection of attributes. So we can also call this composite attribute as attribute set. And next I will explain what is relationship set. For example, there are two entity sets. One is student entity set and next one is course entity set. For example, I want to create one separate table for enrolled in relationship. For that purpose, we need to select two keys from these two entities. Here I will select rule number and here I will select CID. In this relationship table, there are multiple relationships. So we call it as relationship set. Guys, in exam you may get question like explain entity set types and relationship set types. So whenever that question comes in exam, you can write the same answer. Next I will explain what is dominant entity and subordinate entity. For example, let us consider there are two entities. One is loan entity and next one is payment entity. Entity is nothing but table name. I am connecting these two entities by establishing loan payment relationship. Person who has loan will do payments. So if there is no loan entity, there will not be payment entity. For example, I deleted loan entity. If I delete loan entity, then automatically payment entity also gets deleted. So we call this loan entity as dominant entity and whereas we call this payment entity as subordinate entity. Next I will explain Cardinality Constraints topic in DBMS. In a database management system, cardinality represents a number that denotes how many times an entity is participating with another entity in a relationship set. I will give an example so that you can clearly understand what is this definition. For example, let us consider there are two entity sets. One is male entity set and next one is female entity set. As we know, one male will marry to one female. For example, male entity set contains three entities. They are Sanjay, Raju and Shiva. And similarly, female entity set contains three entities. They are Rani, Maya and Durga. For example, Sanjay married to Maya and Raju married to Rani and Shiva married to Durga. Here one male is connected with one female. So we call it as one-to-one relationship. This is one more example. For example, let us consider there are two entity sets. One is student entity set and next one is courses entity set. And student entity set contains 3 entities. They are Sai, Shiva and Ramesh. And similarly, courses entity set contains 4 entities. They are Java, C++, Python and C. For example, Sai selected this Java course and Ramesh selected this C course. And whereas Shiva selected both C++ and Python courses. Here in first entity set, that is nothing but in first table, one entity is participated with multiple entities in second table. So we call it as one-to-many relationship. Here Shiva participated with multiple courses. They are C++ and Python. So we call it as one-to-many relationship. One entity in first table is participated with multiple entities in second table. So cardinality constraint is nothing but how many times an entity is participating with another entity in a relationship set. Guys, constraints are nothing but rules. In this rule is one-to-one relationship and in this rule is one-to-many relationship. Like that we need to apply rules. Total there are two types of constraints in ER model. On that first one is mapping cardinality, or we also call mapping cardinality as cardinality ratio. And whereas second one is participation constraints. I will explain this both in detail. First one is mapping cardinality. Mapping cardinality is expressed as number of entities to which another entity is associated via relationship set. This is definition of mapping cardinality. Here total there are two entity sets. One is student entity set and next one is courses entity set. I am establishing relationship between two entity sets. So we call it as binary relationship set. This is binary relationship set. Binary means 2. For binary relationship set, generally there are 4 types of mapping cardinality. First one is one-to-one, next one is one-to-many, third one is many-to-one and fourth one is many-to-many. I will explain all these 4 in detail. First one is one-to-one relationship. I already explained this one-to-one relationship. Each entity in an entity set can take part only once in relationship. For example, this male is entity set and this male entity set contains 3 entities, Sanjay, Raju and Shiva. And whereas in female entity set there are 3 entities, Rani, Maya and Durga. Here relationship takes place only once. That is, Sanjay married to Maya, Raju married to Rani and Shiva married to Durga. So this is known as one-to-one relationship. Let us assume that a male can marry one female and female can marry only one male. So relationship is known as one-to-one relationship. This is one-to-one cardinality. We will represent cardinality using sets. Here I am taking entity set as capital A and capital B and whereas entities as A1, A2, A3 small letters. And I am connecting one-to-one. This is diagram for one-to-one cardinality. Next I will explain one-to-many relationship. One-to-many relationship is a type of relationship where one entity in an entity set is associated with multiple entities in second entity set. I already explained this example. Here in student entity set, entity Shiva participated multiple times in another entity set. That is, Shiva selected multiple courses, C++ and Python. Here one student selected multiple courses. So there is one-to-many relationship. This is example. One student enrolled in multiple courses. This is example. This is one-to-many cardinality diagram. We will represent one-to-many cardinality using sets. For example, capital A and capital B are entity sets and small a1, a2, a3 are entities in this entity set. For example, student 1 selected one course and student 3 selected one course and whereas student 2 selected 2 courses. So I am connecting a2 with b2 and as well as b3. This is cardinality diagram. Next one is many-to-one relationship. Whereas in one-to-many relationship, one student will select multiple courses, but whereas this time, many students will select one course. I'll give an example. Before that, I will explain definition. Many-to-one relationship is a type of relationship where multiple entities in first entity set are associated with single entity in second entity set. I will give an example so that you can clearly understand this definition. For example, the students is entity set. The students entity set contains 4 entities, Sai, Ramesh, Suresh, Lokesh. And similarly, this courses entity set contains 2 entities, Java and Python. For example, this Lokesh selected this Python course. Now, this student Sai selected Java course, Ramesh selected Java course and Suresh selected Java course. Here, many students will select one course. So, we call it as many-to-one relationship. This is diagram. Many students will select one course. We will represent many-to-one cardinality using sets. So, here this student selected one course and these 3 students selected this B1 course. This is diagram for many-to-one cardinality. Multiple entities in first entity set are associated with single entity in second entity set. Next one is many-to-many relationship. Many students will select multiple courses. This is simple example of many-to-many relationship. For example, students are selected C++, Java and Python. This is one-to-many relationship. And similarly, students are selected C++, Shiva selected C++ and Ramesh selected C++. So this is example of many-to-many relationship. Many students will select multiple courses. So Sai selected C++, Java, Python. Shiva selected C++, Java, Python. Ramesh selected C++, Java, Python. Many-to-many relationship is a type of relationship where multiple entities in first entity set are associated with multiple entities in second entity set. We will represent many-to-many cardinality using sets. Here capital A represents student entity set and capital B represents course entity set. A1, A2, A3, all these are entities in A entity set, and B1, B2, B3, all these are entities in B entity set. So this person selected these three courses, and similarly this person selected these three courses, and similarly this person selected these three courses. This is simple example of many-to-many cardinality. Next I will explain participation constraints. Participation of an entity in a relationship is known as participation constraint. For example, if you consider students entity set, in this students entity set, entity Sai participated in Java, entity Shiva participated in C++ and so on. So participation of an entity in a relationship is known as participation constraints. Participation of entity in a relationship can be either mandatory or optional. For example, if participation is mandatory, then definitely each and every student must select courses. If participation is not mandatory, then some students may select course or some students may not select course. Entity participation can be either mandatory or optional. If entity participation is mandatory, then we call it as total participation. And if entity participation is not mandatory, then we call it as partial participation. I'll give an example so that you can clearly understand what is this total participation and partial participation. For example, let us consider there are 4 students, A1, A2, A3, A4. And similarly, there are 3 courses, B1, B2, B3. Student A1 selected this B2 course and A2 selected this B1 course and A3 selected this B3 course. Here all these 3 courses are participated in relationship. So we call it as total participation because all are participated. So we call it as total participation. But whereas if you consider students entity set, this A4 did not participate in relationship. So we call it as partial participation because in this entity set, A4 did not participate in relationship. I will draw ER diagram for this. This is one-to-one relationship because one student participated in one course. So this is one-to-one. If you see this course entity set, each and every entity participated in relationship. So we call it as total participation. And we will represent total participation with double line. I am drawing here double line. So I will draw double line. And whereas we will represent partial participation with single line. This E4 did not participated. So I am drawing single line. This is example of total participation and partial participation. I will give one more example. This student A1 selected B1 course, student A2 selected B2 course and student A3 selected B4 course. And this course B3 did not participate in any relationship. So I will draw ER diagram for this. Student enrolled in courses. Here all students enrolled in courses. So we call it as total participation. So I am drawing here double line. And here entity B3 is left. So we need to draw single line. This is partial participation. For example, there is another student A4. This A4 student selected this B3 course. So there is total participation for both A and B. So we need to draw double line. This is all about total participation and partial participation. So cardinality constraints are classified into 2 types. Mapping cardinality. Mapping cardinality contains one-to-one, one-to-many, many-to-one and many-to-many relationships. And whereas participation constraints contain total participation and partial participation. Next I will explain generalization, specialization and aggregation in ER model. As the complexity of data increased in late 1980s, it became more and more difficult to use traditional ER model for designing database. Hence, some improvements or enhancements were made to existing ER model to make it able to handle complexity. Guys, from late 1980s, data is increasing day by day. So it became very tough to design ER diagrams by using this existing ER model. So some improvements were made to present ER model in order to handle complex data. Along with these improvements, new concepts were added to this existing ER model. They are generalization, specialization and aggregation. I will explain all these 3 topics in detail. At first, I will explain what is generalization. Before explaining this definition, I will give an example so that you can clearly understand what is generalization. For example, there are 2 entities. One is student entity and next one is faculty entity. As we know, we will represent entity in rectangle. So inside rectangle I written student and inside rectangle I written faculty. Guys, entity is nothing but table name. Student entity contains various attributes like name, roll number, mobile number and age. We need to represent attributes in ellipse. Attributes are nothing but column names. And similarly, faculty entity contains 4 attributes. They are name, ID, mobile number and age. Guys, attributes are nothing but column names. Guys, here name, mobile number and age are common for these both entities. That is, student contains name, mobile number and age, and as well as faculty contains name, mobile number and age. Now what I will do is, by selecting common attributes from these two entities, I will create one new entity. That entity name is person. Student is a person and faculty is a person. So by using these two entities, I will create one new generalized entity. That entity name is person. So I am combining the student and faculty entities and I am using easy relationship. Just write here easy and you need to write easy in triangle. So student and faculty is a person. This is entity and I am selecting common attributes from these two entities. Name, mobile number and age attributes are common. So I will add these attributes in person entity. This is known as generalization. This generalization will follow bottom-up approach. Bottom-up approach is nothing but from two entities, by selecting common attributes, we need to create new entity. That's it. This is known as generalization. So generalization is a process of extracting common properties from a set of entities and creating a generalized entity from it. It is a bottom-up approach in which two or more entities can generalize to a higher level entity if they have common attributes. Properties and attributes both are same, don't get confused. Next I will explain what is specialization. Specialization is opposite to generalization. For example, if you consider generalization, in generalization we will combine these two entities and form a single entity. But whereas in specialization, we will divide single entity into sub-entities. For example, there is one person entity. That person entity contains name, mobile number and age. Now what I will do is, I will divide this person entity into two sub-entities like student and faculty. And I will add these attributes like name, mobile number and age to both student and faculty. And if you want, you can add another attributes like ID and roll number. Whereas generalization follow bottom-up approach and whereas specialization follow top-down approach. Top-down approach is nothing but we will divide single entity into sub-entities. You can remember like this. Generally, many people will grow from bottom to up and whereas some special people, that special people will not grow from bottom to up. They will fall from top to bottom. So specialization is nothing but top-down approach. You can remember like this. An entity is divided into sub-entities based on their properties. It is a top-down approach where higher level entity is divided into two lower level entities. This is specialization. And last one is aggregation. Aggregation in DBMS is the process of combining two or more entities to form a more meaningful new entity. Guys, in aggregation we will combine two entities and form a single entity. And aggregation is used in generalizing reports, business intelligence, statistical analysis and data visualization. I will give an example so that you can clearly understand what is aggregation. For example, there is one training center. The training center will offer some courses like C programming, Java, so on. So I took two entities, training center and courses. I am establishing relationship. That relationship name is offers. So training center will offer some courses. Now person want to join training institute. So whenever any person want to join training institute, he will inquire about training institute like training institute is good or bad, from how many years the training institute is present and so on. He will inquire about training institute and as well as he will inquire about courses like what courses the training institute will provide, like training institute will provide Java, C++ and so on. So person will inquire both training center and as well as courses. So what I will do is, I will create one new entity by combining these two entities. Now this training center and courses are one entity. Now I am combining this training center and courses and I am creating one new entity. Person will inquiry training center and courses. So I am creating inquiry relationship. Inquiry and you can connect to it. Combining two entities to form a single meaningful entity is known as aggregation. Guys, we call this generalization and specialization as class hierarchies with easy relationship. Class hierarchy contains superclass and subclass. If you consider generalization, in generalization student entity and faculty entity, superclass is person. Similarly in specialization, person entity subclasses are student and faculty. So in exam you may get separate question like explain class hierarchies. Class hierarchies are nothing but generalization and specialization with easier relationship. Next I will explain conceptual design with the ER model in DBMS. Conceptual design is the second phase in the database design process. Guys, in database design process, second step is conceptual design, and whereas first phase is requirement gathering. After gathering all requirements from the user, in software company there is database designer. The main duty of this database designer is to design ER diagrams. So in conceptual design phase, we will design ER diagrams. While creating ER diagrams in conceptual design phase, this database designer has several choices like, should a concept be modeled as an entity or attribute? Should a concept be modeled as an entity or relationship set? Should a concept be modeled as a binary or ternary relationship? Or should a concept be modeled as an aggregation or ternary relationship? This is entirely designer's choice. I will explain each of them. At first, I will explain attribute versus entity set. For example, there is an employee entity. This employee entity contains three attributes. They are name, ID and address. For example, I want to give single address like Hyderabad, Delhi, Goa. So if you want to give only single address, then you can select address as an attribute. Here I want to enter single address, so I am selecting address as an attribute. But I don't want to enter single address. I want to enter complete address like city Hyderabad, street Nagol and house number 28-864. I want to enter this complete address. At that time what I will do is, I will select address as an entity. Inside address entity I will create three attributes. They are city, street and house number. Guys, entity is nothing but table name, and whereas attribute is nothing but column names. Here at first I selected address as an attribute, that is nothing but column name, and whereas here I selected address as an entity, that is nothing but table name. Just I am writing here employee has address. I am establishing has relationship between employee and address. Either you can select address as an attribute or entity. It is completely designer's choice. This is all about attribute versus entity. Next I will explain entity set versus relationship set. For example, there is employee entity. This employee entity contains three attributes. They are name, ID and salary. And there is another entity, that entity name is department. This department entity contains dname and did attributes. Employee manages department. Here I am establishing manager's relationship. And here for manager's relationship I am creating three attributes. They are since at what time he is managing, manager's name and budget. How much budget that particular manager is given in order to manage department. Here I took managers as relationship set. But all employees will not manage department. Only managers will manage department. But here I written employee manages department. But this is entirely wrong concept, because employee will not manage department. Only manager will manage department. So what I will do is, I will convert this manager's relationship into manager's entity. Here from employee entity I am deriving manager's entity. And I am assigning all these attributes to this manager. So just I written here employee is a manager, and I am assigning all these attributes to this manager. So manager manages department. Now it is perfect. Here managers is relationship, and whereas here manager is entity. Next I will explain binary versus ternary relationship. If we establish relationship between two entities, then we call those relationship as binary relationship. But if we establish relationship between three entities, then we call those relation as ternary relationship. For example, there are two entities. One is supplier's entity and next one is product entity. As we know, supplier buys product. At first, in order to sell product, at first suppliers will buy products. So just I written here suppliers buys product. I am establishing buys relationship between these suppliers and product. Suppliers has attributes like name ID, and product has attributes like pname and pid. And similarly, customers also buys product. So just I written here customers buys product. So I am establishing buys relationship between these customers and product. Instead of creating two binary relationships, what I will do is, I will create only one ternary relationship by combining the suppliers and customers. So suppliers buys product and customers buys product. This is ternary relationship. If there is relationship between three entities, then we call it as ternary relationship. And next one is aggregation versus ternary relationship. This is ternary relationship. Suppliers buys product, customers buys product. Both suppliers and customers buys product. So what I will do is, I will convert these two entities into single entity by establishing along with relationship. So suppliers along with customers consider single entity. So just I written here suppliers along with customers buys product. Here suppliers along with customers is considered as single entity, and I am establishing buys relationship. This is all about conceptual design. Next I will explain ER diagrams for company, library management system, online shopping, hospital management system, university management system, hotel management system, railway reservation system and bank management system. At first I will explain ER diagram for company. In each and every software company, there will be a database designer. The main duty of this database designer is to draw ER diagrams. In company database system software, I want to create 4 tables. So I will create 4 entities. They are employee, department, dependent and project. Guys, entities are nothing but table names. And each and every entity contains attributes. Attributes are nothing but column names. For example, this employee entity contains attributes like gender, name, employee ID, address, date of joining and date of birth. These attributes are nothing but column names. And here for employee ID attribute, I took underline symbol. So we call this attribute as primary key attribute. Next one is department entity. This department entity contains 3 attributes. They are department number, name, location. And for department number, I took underline. That means this is primary key. And similarly for project, I took project number, name and duration. And for dependent, I took dependent name, gender and relationship. As we know, employee will work in department. So I will connect these 2 entities by establishing works in relationship. We will represent entities in rectangle and attributes in ellipse and various relationships in rhombus. Employee works on project. So I will establish works on relationship between this employee and project. For example, wife, children, father, mother, everyone depends on employee. So I will create one separate dependent entity, and this dependent contains 3 attributes like dependent name, gender and relationship. This dependent depends on employee. So I will establish depends on relationship between this dependent and employee. How many entities you want, that many entities you can create. Guys, in this diagram, employee, department and project, these 3 are important entities. So definitely we need to give primary key for these 3 entities. Next I will explain ER diagram for library management system. Total I took 5 entities. And the first one is user entity. Entity is nothing but table name. This user entity contains 3 attributes. They are name, address and library ID. Only person having library ID can enter into library. So I will consider this library ID as primary key. So I will take underline symbol. Next I will take login entity. This login entity contains login ID and time. For each and every person, login ID will be unique. So I will consider this login ID as primary key. Next I will create librarian entity. This entity contains attributes like name, ID and mobile number. Here I will consider this ID as primary key. In order to enter into library, both user and librarian must log in. So I will connect these 2 entities by establishing have to relationship. In order to enter into library, user have to log in and librarian have to log in. User will borrow books from library. So I will connect these 2 entities by establishing borrow relationship. Books are issued by librarian. So I will connect these 2 entities by establishing issued by relationship. Next one is book record entity. This entity contains attributes like update record, add record, delete record, total number of books available. If any person borrow book or if any person return book, then librarian will add that information in this book record. So librarian maintains book record. So I will connect these 2 entities by establishing maintains relationship. This is ER diagram for library management system. Next I will explain ER diagram for online shopping. Total I want to create 4 tables. So I took 4 entities. They are customers, website or mobile application, admin and products. These are 4 entities. This customer entity contains attributes like name, customer ID, username, password, name, address and email ID. Here I will take customer ID as primary key. So I took underline symbol. In order to purchase products, customer will log in into website or application. So I will connect these 2 entities by establishing login relationship. Admin manages mobile application or website. So I will connect these 2 entities by establishing manages relationship. And this admin contains primary key, that is admin ID. Guys, not only these attributes, if you want you can add any number of attributes. And admin will manage products. So I will connect these 2 entities by establishing manages relationship. This products entity contains attributes like product name, price, category, product ID and availability. Here product ID is considered as primary key. As we know, customers will purchase product. So I will connect these 2 entities by establishing purchases relationship. Next I will explain ER diagram for hospital management system. Total I took 5 entities. They are patient, hospital, medical record, test and doctor. Here patient entity contains attributes like patient name, disease, patient ID, name and address. Here patient ID is considered as primary key. And also here I took hospital entity. This entity contains 3 attributes. They are hospital ID, hospital name and hospital address. As we know, patients will admit into hospital. So I will connect these 2 entities by establishing admitted in relationship. I created separate entity for medical record. This entity contains 3 attributes like patient's record ID, date and problem. Patients has medical record. So I will connect these 2 entities by establishing has relationship. and also hospital as doctors. And this doctor's entity contains various attributes like doctor ID, doctor name, doctor salary, and qualification. As we know, doctor will write test, and this test is performed on patient. So test is performed on patient, and doctor will check patient. So I will establish check relationship. This is ER diagram for hospital management system. Next I will explain ER diagram for university management system. Total I took 7 entities. They are faculty, hostel, student, course, subjects, exams and department. Faculty entity contains attributes like name, faculty ID, department and salary, where this faculty ID is primary key. Guys, entity is nothing but table name, and whereas attributes are nothing but column names. Hostel entity contains attributes like hostel name and hostel ID, where this hostel ID is primary key, and student entity contains attributes like name, roll number, department and mobile number, where this roll number is primary key. And similarly, course entity contains attributes like course name, course ID and duration, where this course ID is primary key. And subjects entity contains attributes like subject ID and subject name, where the subject ID is primary key. And exams entity contains attributes like exam code, room number, time and date, where this exam code is primary key. And department entity contains attributes like department ID and department name, where this department ID is primary key. These are various types of entities in university management system. Faculty, teacher, student. So I will establish teachers relationship between these two entities. Students living in hostel. So I will establish living relationship between these two entities. As we know, student will enroll in course. So I will establish enrolls relationship between these two entities. Faculty has department and faculty takes subjects. Department handles course and department conducts exam. Guys, this is the ER diagram for university management system or college management system. Next I will explain ER diagram for hotel management system. Total I took 3 entities. They are guest, reservation and room. This guest entity contains attributes like name, email ID, mobile number and address, where here login ID is primary key. And room entity contains attributes like room number, beds and number of rooms. Here room number is primary key. And whereas reservation entity contains attributes like reservation number, date and time. Here reservation number is primary key. As we know, guest will request for room. So I will connect these two entities by establishing request relationship. Sometimes guest will book online reservation. So I will connect these two entities by establishing book relationship. This online reservation will reserve room. So I will connect these two entities by establishing reserve relationship. This is ER diagram for hotel management system. Next I will explain ER diagram for railway reservation system. Here total I took 5 entities. They are passenger, ticket, payment, train details and technical supervisor. These are 5 entities. Passenger entity contains attributes like name, gender, age and mobile number. And similarly, ticket entity contains attributes like source, destination, number of passengers, date and time. And similarly, payment entity contains attributes like amount, online payment. This train details entity contains attributes like train number, train name and compartment. Here train number is primary key. And similarly, this technical supervisor entity contains attributes like name, ID and mobile number. This ID is primary key. Ticket is issued to passenger and payment is done by passenger. In order to purchase ticket, passenger will check train details. So passenger checks train details. And these train details are handled by technical supervisor. So technical supervisor manage train details. This is ER diagram for railway reservation system. Guys, not only railway reservation system, but also you can write this example for bus management system. Next I will explain ER diagram for bank management system. Total I took 5 entities. They are bank, branch, loan, customers and account. Guys, you can take any number of attributes and try to give one primary key for each entity. Here for bank, code is primary key. Here for branch entity, branch ID is primary key. Here for loan entity, loan ID is primary key. Here for account entity, account number is primary key. And here for customers entity, customer ID is primary key. Bank has branch, branch offers loan and branch maintain accounts of customers. Customer contains account and customer takes loan. This is ER diagram for bank management system. Next I will explain ER diagram for car insurance company. Total I took 3 entities. They are person, car and accident. Person entity contains attributes like name, driver ID and address, where driver ID is primary key. And similarly, car entity contains attributes like license, model and year, where this license is primary key. And similarly, accident entity contains attributes like report number, location and date, where this report number is primary key. Person owns car and person and car participated in accident. This is ER diagram for car insurance company.